information, we're given what topics are going to come up within various categories. Paper 1 is your non-calculator, and we've been told we're going to have within number, percentage increase, ratio and surds. And paper 2, we've got some more ratio questions and the product rule. So let's look at percentage increase. Percentage increase, so if I said to you I want to increase a value by 15%, it means I want the original 100% plus the additional 15%. So I'm looking at 115% of the original value. And we're going to think of things in terms of multipliers. Because whether it's an increase or decrease, this helps us to calculate things. Now remember, percentage is just a fancy way of dividing by 100. So if we've got 115%, we do 115 divided by 100, which is the same as multiplying by 1.15. So 115 divided by 100 gives you 1.15. This is our multiplier. So if we're finding an additional, so the original plus the 15%, we times it by 1.15. Let's take a practical example. So if we've got something like 50 meters and we want to increase it by 15%. So we could think about it in two ways. We're a non-calculator, remember, revision from GCSE, or from the stuff that you would have done earlier on, is that if you want to find 10% of anything, you divide by 10. So 10% of 50 would be 5. 5% would be taking that 10% and dividing it by 2, so 2.5. So altogether, 15% would be 7.5. So remember, if I'm increasing it by 15%, I'm adding that extra bit. So it's the 100 plus the 15. So that would give me 57.5 meters. This is going to make a lot more sense. We're going to go look at some exam questions. Okay, so question 1. The value of x is 50% more than the value of t. So we're starting off with t. We've got the original 100%. We're adding 50%. So we've got 150%. So my multiplier is 1.5. So I know that 1.5 lots of t equals x. Now I've got the value of y is 10% less. So I've got my original 100%. I'm minusing 10% to give me 90%. When I divide that by 100, I get 0.9. So I know 0.9 of w is y. The next line tells me x equals y. So I can make these two equal to each other. So I get 1.5t equals 0.9 w. I want to end up with t over w and an answer as a decimal. So I'm going to divide both sides by w. I get 1.5t over w equals 0.9. I don't want the decimal on the other side, so I'm going to divide that by 1.5. So I get t over w is 0.9 over 1.5. Decimals are annoying, times everything by 10, 9 over 15. I can cancel that down to 3 over 5, which is 6 over 10, which as a decimal is 0.6. Now you might have got there quicker, your arithmetic could be better, and that's not a problem. Okay, question 2. P increases by 25%. So I've got my 100%, add my 25% to give me 125%. Right, so originally P is 4x. I'm increasing it by 1.25. Right, now we should know 25% is a quarter. A quarter of 4 is 1. If we're taking the original amount, adding that 1 on, we're now going to have 5x. Q decreases by 40%. So instead of adding, we're subtracting. So we end up with 60%. So we're taking our Q of 7x and multiplying it by 0.6 because we're taking that 60% and dividing by 100. So we could do 7 times 6, which gives us 42. There's one number behind the decimal place, so we need to divide it. So 4.2x. We're told that this new P of 5x is 28 greater than Q. of 4.2. So when we take them away from each other, we get 28. 5x minus 4.2x is 0.8x, which is 28. So then all we need to do is we can do 28 divided by 8. So if you do 28 divided by 8, you're going to get 3.5. But because you've got the 0.8 on the bottom, you times it by 10 and you get 35. So let's double check that arithmetic because we said we might come up non-calculator. 28 over 0.8. One easy way to do it is to times top and bottom by 10. So you get 280 over 8. And then you could calculate that. 28 into 8 is 3, remainder 1. Sorry, not remainder 1. So then we can end up with, so 28 divided by 8 is obviously, let's do this properly, as opposed to me showing you. So we're going to get 3. 3 times 8 gives us 24, so we've got 4 left. 8 into 40 is 5, and we get the 35. Sorry. Double checking you're happy with the arithmetic because you do have the non-calculator paper there. Right, so now let's look at ratios. We're going to look at ratios. Now, ratios are just fancy ways. So if you've got A to B, it's the same as saying A divided by B. So now we've got A to B to C, and we want everything in terms of the same thing. So I'm going to check out A and C. So A to C is 5 to 2. So that essentially tells me A over C is 5 over 2. So 2A is equivalent to 5C. That means 4A's will be the same as 10C's. So we're just going to put everything in terms of C. Could have put them in B's or A's, it wouldn't have mattered. There's no good reason why I chose C, but I think it's going to work out nicely. Hopefully it does. Then we're going to look at B to C. B to C is 3 to 2. So B divided by C is 3 over 2. So that tells us 2B's is equivalent to 3C's. So we have 3B's on the other side. So 1B would be 3 over 2C. So 3B's would be 9 over 2C. So now if we plug that all in, we've got 4A, which we said was the same as 10C's. So 10C minus C equals 9 over 2C, which is the same as 9C to 9 over 2C. And the C's and everything cancel, and we will end up with 1 to 1/2 times both sides by 2, and we get 2 to 1. So 2 to 1 is my ratio, and I've gone through a long way of doing that just to show you the relationships. You may have come to that, it's only 2 marks in 1 line, and that would have been perfectly fine. Next bit, we're given m(n) equals 2 to 5. So that tells us m divided by n equals 2 over 5. And we want m in terms of n. So we want m equals something. So I'm going to multiply the n up here, and we're just going to get m is 2/5 n. Now we need that for the next bit, so let's write it up here. M equals 2/5 n. So now we're given a to b, so remember we can write that as a fraction, is equal to 10m over 3n. Oh, we don't actually need to write it as a fraction, but never mind. Right, now we want to get rid of essentially the m and the n's. But let's see what we know. We know that m is equal to 2/5 n. So 10m will be 10 times 2/5 n. That's going to cancel and give me 4n. So now we've got a over b is 4n over 3n. We can cancel out the n's, and we can see a to b is 4 to 3. So our answer will be 4 to 3. Okay, rationalizing a denominator or a surd, rationalizing a surd. We do not like surds on the denominator. So on the bottom, as mathematicians, we like everything clean and pretty. So to get rid of a square root value, we square it. and we get whatever was underneath. However, if we have more than one thing underneath, so we want to get rid of it, we need to use the difference of two squares. So for example, if we've got root a plus b, we need to multiply it by root a minus b. And what that will do is we'll square the first number, which in this case would be a, always a minus the second value squared. And that's typically the questions you're going to get in further maths. You're going to have, very unlikely you'll get just a single value. You'll probably have to use the difference of two squares. Excuse me. Right, so we've got root 3 minus 7 over root 3 plus 1. We're going to multiply top and bottom by the same thing on the bottom, but instead of a plus sign, we're going to have a minus sign there. Root 3 minus 1. All right, so let's open that out. We've got root 3 times root 3, which is just 3. Root 3 times minus 1, so minus root 3. 7 times root 3, so minus 7 root 3. Minus 7 times minus 1 to give us plus 7. All over root 3 times root 3. Now this is the difference of two squares. So looking at this example here, so that's going to give us 3 minus 1. Right, let's simplify everything. 3 plus 7 gives us 10. Minus root 3 minus 7 root 3 gives us minus 8 root 3. All over 2. We can divide everything on the top by 2. And we get 5 minus 4 root 3, which is in the same form as we're expecting it. So let's have a look at another example. It tells us to simplify fully. Now I look at that and the first thing I'm going to go is root 300 seems a bit big. Let's see if we can simplify that. So that's the same as root 3 times 100. Root 100 is 10, so I get 10 root 3. So now I've got 24 minus 10 root 3 over 4 root 3 minus 5. And we want to rationalise that denominator. So we're multiplying top and bottom by 4 root 3 plus 5. Okay, so we've got some big numbers here. Now to be fair, this question was actually in a calculator paper, but there's no reason you shouldn't be able to do the mental arithmetic for it. You've got 24 times 4 to give you 96 root 3. 24 times 5, and if you want to do that quickly, think to yourself 24 times 10 is 240. And then what you want to do is you want to half that. So you get 120. So plus 120. Minus 10 times 4, which is 40, times by 3 to give you minus 120. Minus 10 times 5 to give you minus 50 root 3. And on the denominator, you're going to square the first number. So you've got 4 root 3 squared, which is going to give you 48 because it's going to be 16 times 3. Minus 5 squared, which is 25. Right, so let's clean that up. The 120s cancel. We've got 96 minus 50. So we've got 46 lots of root 3. And then we've got 48 minus 25, which gives us 23. That cancels and gives us 2. So our final answer after all that work is just 2 root 3. The final topic that we're going to look at is the product rule for counting. Now the reason it's called the product rule is that product means times. So you're multiplying all the different possible outcomes, okay? So your product essentially means multiply, and you're looking for all the different outcomes. So let's have a look. Our first question asks us how many odd numbers are greater than 30,000. So that's our important bits of information. We want it to be an odd number. Okay, so an odd number can't end in an even number. So that rules out 2, rules out 4, rules out 6, and rules out 8. So our last value, the only possibility is 7, okay? We want it to be greater than 30,000, so my first value can't be smaller than 3, so we can't use 2. So the only options are 4, 6 and 8, because remember 7's been used up. So my first value has 3 options. My second value can be any number except for the 7, so that rules it down to 4, and except for the one I just used as my first value. So there's only 3 options. So now those 3 options left over, one of them can be used for the third value. There's only one left for the fourth value, and there's that 7 there. So we get 3 times 3 times 2 to give us 18 possibilities. The final question, which is also on the product rule, you're looking at digits 2, 4, 5, 6, 7 and 9. You want them to be greater than 60,000, nothing is repeated, and an important bit of information here is you're using some or all of the digits. So we're thinking how many integers can be made. Now, we could have all 6 digits, at which point it doesn't matter what the first value is. So if we look at 6 digits, you can choose any number, because even if it's 2, it's 200,000, which is bigger than 60,000. So here we've got, could be any of the 6 numbers. The next one is any of the 6 except for the one you used to begin with. So that's 5, and then 4, then 3, then 2, then 1. And so this is a calculator paper. This is actually called a factorial, but you could type it into your calculator. So you do 6 times 5 times 4 times 3 times 2, and that will give you 720. Now, if we were to use 5 digits, we want it to be bigger than 60,000. So the only options for the first number are 6, 7 and 9. So we've got 3 options for the first number. For the second number, it can be any of the 6 except for the one we've used to start with. So we've got 5 options. And the same for the third number will follow suit, will be 4 digits. The fourth number will be 3, and the fifth number will be 2. So we end up with 3 times 5 times 4 times 3 times 2. So 360 possibilities. So the total will be 720 plus 360, which gives us 1080. So we've got 1080 possible solutions. Expanding triple brackets. The easiest way to show you this is actually to just take an example. So here's an exam question. You've got to show that we've got a triple bracket minus another x multiplied by a quadratic, and we're looking, and then we're going to have to factorize it afterwards. So let's take the first 2 terms. And I'd always suggest you make your working super clear. In case you make a mistake, you're getting marks each time you're multiplying out. So if I take these, I've got x times x. So I've got x squared plus x plus 3x plus 3. So altogether, I've got x squared plus 4x plus 3. And out of the 5 marks, that's essentially 1 mark. I'm now going to take my quadratic, which I've multiplied out, and I'm going to multiply it by x plus 4. And when I do that, I multiply everything by x first. So x cubed plus 4x squared plus 3x plus 4x squared plus 16x plus 12. Right, and then you're going to simplify that. So altogether you end up with x cubed plus 8x squared plus 19x plus 12. Right, so that's opening out that first batch. Now altogether you've now got 3 marks. So we've got the other 2 marks to get, and we take what we've done, 19x plus 12 minus, and remember it's the whole thing minused. So what I would do is actually take every number and every value, or not number, they're not numbers or values, every letter or expression within that bracket and multiply it by minus x. So you're not doing too many lines. and you're not confusing yourself. Because if you're going to go wrong on this, the likelihood would be that you would go wrong when you're opening out that expression. So we've got x cubed minus x cubed, so that disappears. 8x squared minus 7x squared, leaving us with x squared. 19x minus 11x, leaving us with plus 8x. And then we've got 12. And we want to be able to factorize that. So I'm looking for factors of 12, which add up to 8, which is 6 and 2. So there's our first expanding triple brackets. Right, next we're going to be looking at a question where they don't give you something and they talk about coefficients. So remember, a coefficient is effectively the bit in front of. So the coefficient of x squared is the bit that's going to be in front of your x squared. Right, so let's open this out first. So we're taking the whole of this bracket and multiplying it by x. So we get x cubed plus 5x squared plus kx. We're now going to take the whole of the bracket again, and this time we're going to be multiplying it by minus 3. Minus 3x squared minus 15x minus 3k. And we want to know our coefficient of x squared. So I'm looking for everything that is in front of an x squared. So that's in front of an x squared, and that's in front of an x squared. And we know that's equal to everything that's in front of the x. So in front of an x, we've got plus k and minus 15. So now we've got 5 minus 3 equals k minus 15. So we'll have 2 equals k minus 15. Therefore, k equals 17. So k equals 17. Right, next questions. Now we've got changing the subject of the formula. Now I know you guys have been doing this, particularly if you're doing further maths, since probably year 9. But let's see and let's look for the most efficient method. So this would also be exactly the same type of question you would get in a level 9 question in your maths paper. Okay, so let's have a look. We want to rearrange, we want to make P the subject. Now we don't like things on denominators to start with. They just make life a little bit difficult. So let's get rid of anything on the denominator. So if I have a look, I've got P and I've got 3P. I'm going to take the largest value, because it's a multiple of the other one, and multiply everything by it. So if I multiply everything by 3P, I get 3PM. If I take this and multiply it by 3P, the P's going to cancel, and I'm going to left with the top of it multiplied by 3. And if I multiply the last one, I'm going to end up with that. Now what I want to do is open everything out and put all my P's onto the left-hand side. So I've got 3PM equals 6P plus 3 plus P plus 5. So now I'm putting all my P's onto one side, 3PM, and I've got 6P plus P, so I can move those, so minus 7P, equals 3 plus 5, which is 8. And the next step is you want to take the P outside the bracket. So 3M minus 7 equals 8, and you should then be able to see P equals 8 divided by everything in that bracket. Now you may have moved it the other side. You may have minus 8 equals 7 minus 3m, which is essentially this expression times by minus 1. And that's totally fine as well. So whichever answer you got, it's the correct answer. So you may have it written in a slightly different form. It would still be the right answer. Okay, we're going to use that same strategy for the next bit. So we look at the denominator. Anything on the denominator, we've got x, y, and y. So, okay, we take the one with the most things, which is x, y, and I'm going to multiply everything by x, y. If I take the first term and multiply it by x, y, I'm left with 1. Take 4 and multiply it by x, y, I'm going to get 4xy. if I take 3 over y and multiply it by xy, I'm left with the y's cancel and I'm just left with 3x. Right, now I've got all my x's already on the same side of the equation. So I can rewrite this just because we're used to it. I think it looks a bit prettier having the on the left hand side. Remember, all this means is like, I don't know, 2 plus 3 equals 5. You could write it as 5 equals 2 plus 3. It doesn't matter as long as you swap it all. I'm going to take x outside the subject, outside the bracket even. So we get 4y minus 3 equals 1. So now we're going to divide by 4y minus 3, leaving us with x equals 1 over 4y minus 3. Again, you might have done it a slightly different way. It looks slightly different. As long as the expression is the same, you're okay. You've got it correct. Okay. Next one. Simplify. Right, whenever you see simplification, you're going to think factorize, factorize, factorize. Take out common denominators. So even if you can see everything, in this case, there isn't anything too obvious, but say you could see everything could be divided by 2. Doesn't matter, factorize first. So at the top, I'm going to take out of the bracket, if I have a look with the numbers, 15 and 5, I can take 5 outside. X squared and x, I can take x outside. And y squared, I can take y outside. So this is going to be multiplied by 3x, and this one is going to be multiplied by y. On the denominator, so the bit on the bottom, I'm going to say, well, from 12 and 4, well, both numbers go into 4, and that's about it. So I'm going to get 3x minus y. And what you notice is these two cancel out beautifully, and we get 5xy over 4. Okay, let's try this one. All right, so we look at the numbers again, and on the top we're going to go 8 and 50. So we can take out 2. They're both even numbers. And it's x cubed and x. So I can take x outside the bracket. So if that's not clear, that should be 8x cubed minus 50x on the top. And then we're going to have 4x squared inside, and I'm going to have minus 25. Right. And then we'll have 2x on the bottom, and this hopefully is a double bracket. So I'm going to say, however you do your, however you factorize, that's totally up to you. You could do 6 times 35. You could look at it and go, well, I know I've got 2 numbers that multiply to 6, and I've got 2 numbers that multiply to minus 35. There's various methods to do the factorization. We'll make sure there's a separate video because that obviously applies to GCSE as well. But I'd like to think you can do that if you are at this point in your, if you're doing your further maths. If you can't, not a problem at all. My hint would be, if we have a look at the top, hopefully you recognize it's a squared minus b squared. So we know that's a difference of 2 squares. So we're going to take the top and we can write it as 2x plus 5, 2x minus 5. And because they're asking you to simplify, you would recognize that one of your brackets has to be 2x and 5, at which point you can then figure out the other bracket. Right, so let's cross everything out. Now it's all multiplied that we can by each other, leaving us with 2x plus 5 over 3x plus 7. Remember, everything needs to be multiplied by something in order to cancel it out. Otherwise, you can't cancel it out. So be really, really careful with that. No crossing random x's out. If in doubt, think about what you would do with numbers. Okay? So something that sometimes when we're doing the algebra, we get a little bit confused, but think, what if they were numbers? So if I had 5 plus 2 over 5 plus 1, I can't just take out the 5s. It makes no sense. So it's 7 over 6 is definitely not the same as 2 over 1. Right, some more factorization. And here is where the difference comes between your GCSE and your further maths. Right, we've got something like this and you're like, what do I do? I know we've got squares. So you see squares and you think, okay, 2 brackets. Okay, I know that the first value times the last value has to give me 6x squared. And I know the last one times this one gives me minus 20y squared. So we're going to go about and think about how we do that. But hopefully you realize before you even start that everything goes into 2. So I'm actually going to take 2 outside the entire thing first. So I get 3x squared plus 13xy minus 10y squared. Right, so I got to this point and it makes it easier now because there's only one way to get 3x squared. I've got to have 3x and x, right? Which makes it a little bit easier because now I'm thinking of 10y squared minus 10y. Now I know if I use 10 and 1, 10 times 3 is 30, not going to give me 13. And then 10, if I had a 10 here, if I had a 10 over here and a 1 here, I've got 10 and 3, but there's no way for that to become minus 10. Because even if I had minus 10x, and then this would have to be plus, and then we're not going to get 13. So we know we're not using 10 and 1. Other factors of 10, 2 and 5. If I had a 2 here, I'm going 3 times 2 would be 6. And then I've got 6 and 5 together, they're not going to give me 13. Let me try the other way round. 3 times 5, 15. And multiply these 2 together. If this was a 2, we're like, okay, great. 15 minus 2 gives me 13. So the way that you think about it is if this is a negative here, you know that you want, so if this is a minus, you know that you're taking away these 2 multiplied by each other to give you this. So we end up with 3x minus 2y and x plus 5y. Another way that you can do this is you can remove sort of the x or the y, and then as long as you put it back again. So for example, if it's easier for you, say I had 3x squared plus 13x minus 10. Okay? And I know that you might use the method where you do 3 times minus 10 and you get minus 30. And then you're looking at factors. So you go, how can I get 13 from that? So I've got 30 and 1, that doesn't work. 2 and 15, that works. So I can do 3x squared plus 15x minus 2x. So I replace. So this is made up of these 2. Minus 10. Then I take my first 2 terms and take a common factor. In this case, it's 3x. And I get x plus 5. And I can take x plus 5. I want x plus 5 here. So I get minus 2. So factorize, this gives me 3x minus 2, x plus 5. And then what you can do is the numbers on their own, put the y back in. That's also a perfectly valid method. So my final answer, don't forget the 2 there, is 3x minus 2y, x plus 5y. I hope that makes sense and I haven't overcomplicated it. But if you find that difficult, get rid of one of the letters. So the one that's at the end, factorize and stick it back in again. Okay, index rules. Right, so we know from GCSE, we know if we've got x to the power of something, the x has to be the same, so that base number has to be the same. We're going to get a plus b. We know when we divide, we can take away the powers. We know when we do everything to the power, we're actually multiplying. And then we come to things that are a bit more complex, where we know that x to the 1 over n will be the nth root of x. And x to the minus n is 1 over x to the n. So we've got our rules. And also, always, 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 x to the power of 0 is always 1. Now, obviously, when we move things to the other side, we're going to do the opposite. So in this question here, you've got 3 minus root x to the third equals minus 2. Now, to the power of a third means the cube root. So what's the opposite of cube rooting? So that's going to be cubing. So for both sides, I'm going to cube, which means it gets rid of the third on one side, and I've got minus 2 cubed. So we've got minus 2 times minus 2 to give us plus 4, times minus 2 to give us minus 8. So we get 3 minus root x equals minus 8. I can take away 3 from both sides. So I'll get minus root x equals minus 11. They're both negative, so I can just make them positive. Root x is the square root of x. The opposite of square rooting is to square it. So 11 squared gives us 121. Here they're telling you what to do. But if they hadn't told you to multiply both sides by x to the half, how would you have known that was what you needed to do? So the way that you could have looked at this is to say 2x to the power of 3 over 2 minus 3x to the half equals 7. And because x is to the power of minus a half, we know that it's on the bottom. Because remember, x to the minus n is 1 over x to the n. The 7 is not to the power of anything. The 7 doesn't also go on the denominator. Be very careful about that. Okay, so I'm looking at that. I don't like things on the denominator. So I'm multiplying everything by x to the half. So I get 2x to the 3 over 2 times by x to the half minus 3x to the half times x to the half equals 7. When we times indices, it's the same as adding them. So 1.5 plus a half is going to give us 2. A half plus a half just gives us 1. So we get 3x. And we can bring the 7 over. And there we go. We've got a quadratic again. And because it says 3 significant figures, we know that we're going to be using the formula. If it's a calculator paper, you can just stick it into your calculator. And it will be a calculator paper actually, because you won't be able to do the square root without it. So you can put it into your calculator and sort of work backwards. The other alternative is to use completing the square. So in your calculator, if you've got the ClassWiz calculator, you can tell menu, equation function, polynomial, degree 2, and we're going to do 2 minus 3 minus 7. And it gives us our roots, and it will give us our answers. But because we're asked to show our working, you could either write out the formula. So there's 2 methods to do this. So if I say method 1, you're going to say a equals 2, b equals minus 3, c equals minus 7. And you know that x equals minus b, x equals minus b plus and minus the square root b squared minus 4 times 2 times minus 7 over 2 times 2, and then just read off your answer. So we're going to read off our answer. So x equals 2.77 or minus 1.27. Now, which one isn't valid? Remember, we can't take the square root of a negative number. It's illegal. Dividing by 0 and square root of a negative number. if x was minus 1.27, over here, where you've got x to the half, you would be taking the square root of a negative. So, to cross through that, that's not valid. So this is our answer. That's the first way to do it. And you're just sort of writing out your entire formula and then using your calculator. The other method, so say method 1, method 2, would be using completing the square. So step 1, I would take that equation, and because it's got an equal sign, I can divide it by 2. So x squared minus 3 over 2x minus 7 over 2. I can now complete the square. So I can do x, half what's in front of the x, 3 over 4, squared minus 9 over 16 minus 7 over 2 equals 0. And you could double check that was correct because your calculator also gives you the minimum, which we can see is 3/4, and the y, which is minus 65 over 8. And then we can rearrange that. So we get x minus 3/4 squared equals 65 over 8. Take the square roots, you get plus and minus, and you end up with exactly that. So it doesn't matter which way you do it, you're going to show you're working, even if you've just plugged it into your calculator, and your answer is 2.77. Right, binomial expansion. Okay, so you've learnt this using Pascal's triangle, I assume, because that's how normally we learn it there. So let's draw up Pascal's triangle. We're going to the 6th term, to the power of 6 rather. So remember Pascal's triangle is because if you have a plus b, you've got 1a to the power of 1. You've effectively got 1a plus 1b. So 1 and 1. If you've got a plus b squared, you're going to have a squared plus 2ab plus b squared. So the coefficient of the first one is 1. In the middle it's 2, and then it's 1. And what we start to notice is when we add these two, we get that, and there's always 1s on the outside. So if I had a plus b cubed, I get a cubed plus 3a squared b plus 3ab squared plus b cubed. So every single time, the first term is going down in power, and the second term is going up in power. Okay? So if we think about this, we've got 2x plus a to the 6, and we're looking for the x to the 4 term. So in the first one, so if we go all the way, so 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Right. In the very first term, this one here will be just 2x to the power of 6. Then it's going to be 2x to the power of 5, 2x to the power of 4. And we realize that happens at this point here, when this is our coefficient. So what we know is if we had a plus b to the 6, I would have, like I said, a to the 6 plus this coefficient here, 6a to the 5b plus 15a to the 4b squared. So when we get there, we stop because we've got our to the power of 4. And we're going to say, well, let's substitute things in. So here, if you like, if I match things up, our a is the same as, and I know they've used the same letter, it's very annoying because it's not a in this case. A is 2x and b is what they've called a here. So let's stick that into our formula. So 15, 2x to the power of 4, and then you've got a squared. Right, so let's open that out. 15 times 2 to the 4 times x to the 4 times a squared. Okay, So we know if it was actually in a calculator paper, but let's say it was in a non-calculator paper. 2 to the power of 4 is 16. 16 times 15 is going to give you 240. So we've got 240. We're not worrying about the x to the 4 goes at the end. A squared x to the 4. So now what we're looking at is we're looking for the coefficient. Remember, the coefficient is the bit in front of. So the bit in front of x to the 4 is 240 a squared. So 240 a squared we know is the same as 60. Right, rid of our zeros. A squared is going to be 6 over 24, which is a quarter. If I take the square root, remember we get plus or minus. So the square root of 1 is just 1. The square root of 4 can be plus or minus 2. So I get a half, or I get minus a half. So a half or minus a half. Okay, now we're going to go to linear and quadratic inequalities. Linear inequalities, a lot more straightforward. You treat it like an equal sign. If you've got a double one, whatever you do to one side, you have to do to the other. With a quadratic inequality, I'll show you how to do it if you don't have your calculator with you and it's a non-calculator paper. However, if you have your calculator, you can always check things because you've got an inequality button on the class whiz. If you haven't got the class whiz, that's fair enough. If you're going on to do A-level, you will need it for A-level, so you might as well get it now if that is a possibility. Okay, so let's take the first question. It tells us to work out, and they bold things for a reason, that's there to help you, the integer values. So these are the whole numbers. But first, we want to get x on its own. So if we have a look, we've got 4x plus 3. So we're going to minus 3, and because there's two sides to this, we're going to minus 3 on both sides. So if I do minus 5 minus 3, I'm going to get minus 8. 13 minus 3 is going to give me 10. Now I want x on its own, so I'm going to divide by 4. So when I do that, I have to divide both sides by 4, which leaves me with x minus 8 minus divided by 4 is minus 2. And then we've got 10 divided by 4, which is the same as 2.5, 5 over 2. So let's write it because we're trying to 2.5. And now we want to list all our integer values. So we know x is greater than minus 2, but not equal to, because it doesn't have the equal sign. So it's not going to be minus 2, it's going to be minus 1. Next one up, 0 is an integer. 1, 2, and I can't go any further. So those are all my integer values. Right, work out the range of values for which x squared minus 11x plus 28. Step 1, factorize. So I'm going to do that. X and x. 20 factors of 28. There's a plus here. So factors of 28 that add together to give me minus 11. So we're going to say, well, 7 and 4, and it's going to be minus and minus. And so I've got what we call our critical values. So my critical values are 7 and 4, because if I was to solve this equal to 0, I'd get 7 and 4. There are a few ways to do this. The first way is, which you may have learned, is to think about it's a positive quadratic, so it's a smiley face. It goes through 4 in my very dodgy graph there. And we're looking for wherever this graph is above the axes, meaning if I take any value of x and I read off the y, it's always going to be positive. Now it's only ever going to be either between the two numbers or outside of the two numbers. It's never going to be anything else. You're never going to get a random mix. So either your values are going to be between 4 and 7, or they're going to be less than 4 and greater than 7. So if I'm here and I go, that's positive. Whereas if I go in between and I read off a value, it's negative. So I want where it's positive, which in this case is when x is less than 4 and x is greater than 7. Okay, right. The other way to do this, or it shouldn't really be and, but we don't even need that actually. Let's take that and out and not confuse you. So, because you wouldn't have two answers at the same time. So technically, me sticking an and there wouldn't be correct, although you would get all the marks. So you'd have, let's have a look, and you'd make sure you put them both in your answer. Right, like that. The other way is we've got this 4 and 7. We know it's got to be between them or it's going to be outside. So I pick a number. 0 is usually the best number if 0 is not one of your answers. So I could have 0 minus 0 would just leave me with plus 28. And you'd say, is 28 bigger than 0? Yes, it is. Which means 0 has to be part of my solution. 0 is less than 4. So it's the outside bit. So x is less than 4 and x is bigger than 7. So I think a graph sometimes is easiest to see. It's that region there, but you can do it any way that makes sense for you. Okay, let's have a look at the next question. Identities. Because this is a new idea, I think a lot of students find this difficult, but actually it's one of the easiest topics. So your general method's going to be, you're going to open up all the brackets on your left-hand side and your right-hand side, and then you're going to match coefficients. Okay, so underline, highlight. I use a highlighter when I do this. In the exam, it doesn't matter as long as you're working. It's all done in your correct color pen and, you know, you put it at the bottom and your final answer is really clear. So we're going to take our left-hand side and open out the brackets. So when we do that, we get 3a times 2x, so 6ax minus 3a plus 4ax plus 20. So I've done 3a times 2x, 3a times minus 1, plus 4 times ax, plus 4 times 5. And that's equivalent to 60x plus b. So now I'm going to say to myself, on the left-hand side, what is in front of the x's? So on the left-hand side, I've got, let's redo that. On the left-hand side, I've got 6a, that's in front of an x. Take the sign with it, and plus 4a. Okay, and on the right-hand side, I've got 60. Then I'm going to take everything that doesn't have an x. Remember, a is just like a value. That's not an x or an x squared or anything we need to worry about. So we take minus 3a, we're adding 20, and we've got b. Right, so now let's write all the bits that we had in yellow together. So we've got 6a plus 4a must equal 60. Because that's the coefficients of the x. So we end up with 10a equals 60. So therefore a equals 6. Right, next one. We now got minus 3a plus 20 equals b. But we already found out a, so we can substitute it in. So we're going to do minus 3 times by 6, right? So minus 18 plus 20 equals b, so b must be 2. And don't forget to write your answers into the answer box, especially if you're somebody who's working, can sometimes get a little bit messy, so it makes it super clear. Right, so let's take one that's a little bit trickier, or, you know, has more than one letter where you have to think about it a little bit more, but not really. Hopefully this is okay. Do exactly the same. We're going to take the left-hand side. We've already got mx, so that's easy, plus 4, and now we've got minus 2 multiplied by x. So we've got minus 2x. And then always take the sign in front of the number of your bracket. That way you're never going to get yourself in a muddle. Minus 2 times p, so minus 2p. Okay? And that's equivalent to 6x plus 6. Right, we're going to take everything in front of our x's. So I've got an m in front of an x and minus 2 in front of an x. And here we've got 6 in front of an x. Then everything else that's not in front of the x. So plus 4, minus 2p, and plus 6. So now what I've ended up with is my yellow bits, if you like, the bits in front of the x, m minus 2 equals 6, and 4 minus 2p equals 6. So the first one's going to give us m equals 8 by adding 2 on both sides. Here we've got to do minus 4 first from both sides. So we get minus 2p equals 2. So p equals minus 1 when I divide by minus 2. Go back and fill out. So 8 and minus 1. Okay, so we're first going to be looking at functions. Functions essentially is something in and something coming out. So when you think about it, you've got to think about your domain, which is all your x values, is the things coming in, and you have your x and you've got your range, and that's what's coming out, so your y values. And what I'm going to do is I'm going to split that into different types of graphs. A linear graph, which is essentially just a straight line of y equals mx plus c. I've got y equals mx plus c here. And of course, we just use fx instead of y. It's just a fancy way of doing it. So if, for example, I told you x is bigger than, I don't know, let's say this is 3, I don't know what the equation is, and this is 6. If x is bigger than 3, that means fx must be bigger than 6, because for a linear graph, it's just all the way. And this would be my domain, and this would be my range. The ones that are a bit weird are like your quadratics. Because, for example, imagine, say this yellow bit is my domain. So they give me the x values between whatever this is and whatever this is. And they said to find the range. If you just substituted the points in, you would literally only be finding, so your y value here, you'd only be finding this bit. You'd be missing out all this bottom bit. So with a quadratic, it's better to sketch it and then have a look at whether you have a minimum point or a maximum point. So the range is the smallest y within the bit that you've highlighted and the biggest y coordinate. So that's the only place, well, one of the places that can be a little bit strange with the sketching, but usually it's 1 or 2 marks. If it's not making sense, move on. There's more marks to be get some other places. Okay, so the first one we've got is GF4. Now, if we have any kind of function, so any kind of gx or fx, so if gx equals blah, 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 and I want to substitute a number into here, it means wherever there is an x, I am putting that number. Now, if we have something like here where we've got GF4, what it's saying is it's saying G of f of 4. So we work from the inside out. So we're first going to find F4. F4 just means I'm replacing the x with a 4. So I've got 3 times 4 squared plus 6, which is going to give me 4 squared is 16 times 3 plus 6 is going to give me 54. And now I've got G of f of 4, which I've worked out is 54. So that's going to be the square root of 54 minus 5. Now it's telling you in the question that x has to be bigger than 5. So even though you can do plus or minus, so you'll get the square root of 49, which you know could be plus or minus 7, you're not going to have the negative value because you know that x has to be bigger than 5. So your answer will be 7. The next bit is show that fgx can be written in that form. So remember, we're putting g inside of f. So it's always the second one inside of the first one. So wherever there is an x in f, we're putting this entire thing. So we're going to have 3 square root x minus 5, and all of that is squared plus 6. Now a square root and a square just cancel each other out. So you end up with 3x minus 5 plus 6. But that doesn't look how they want it to look. So we're going to open out the brackets. 3x minus 15 plus 6, which is 3x minus 9. I'm going to take 3 outside the bracket, and we get x minus 3, and that must be correct, because if you have a look, they've told us that this and this have to be the same number. We've got 3 and 3 there. So it's kind of nice when you get the right answer, or you can see that your answer is probably correct. Okay, so this is a prime example. We've got f of x is x cubed minus 2. Now let's think about what x cubed looks like. Forget the minus 2 for the moment. So what does a cubic graph look like? So you're going to have x cubed is the sort of curvy shape. And the way you know it's a positive x cubed is if you go from the low to high, you see you've got a positive line. If it was a negative x cubed, it would be that way around, because if you went from here to here, you've got a negative line. Okay? Now what are we doing to that x cubed? We're shifting it down by 2. So what we're actually doing, the graph that we're actually looking at is going to look something like, so this whole graph has been shifted down, so it's crossing at minus 2, so it's going to be something like that. And it's telling you x is less than or equal to 3. So we're like, okay, so 3 is on the positive side. If y is 0, the cube root of 2 is going to be smaller than 3. So 3 is somewhere here. And we could read off a coordinate here. And we know this graph is going to keep going up, up and up and up. So because we can picture the graph, it makes working out domains and ranges really easy. So all we're going to do is we're going to say f of 3 equals 3 cubed minus 2, right? So 27 minus 2, which is 25. And we can say that's 25. If it was bigger than 3, it would be everything bigger than that. But they've actually got less than 3, so we know the answer's always going to be less than that. So it's a range, so we write fx, and we've got less than or equal to 25. So you think about, what bit do I want? I want everywhere smaller than 3. And what does that mean for the y's? Everything smaller than 25. Okay, I've got a quadratic now. So we've got 5 minus x squared. So this is a negative quadratic, right? So again, sketching it is the easiest way, but they're never going to be difficult ones. So if we think about x minus x squared, it's going to be a sad face, right? And it's going through the origin. But this one has been shifted up by 5. So it's going to do that. Okay. Now I want to know between minus 2 and 1. So the starting point is literally, and you will get, look at this, it's only 2 marks. So the worst case scenario, if you substitute these 2 numbers in and you write something down, you're probably going to get a mark potentially. And it's okay. So don't get yourself, I have students who get stuck on the domain and range question and then don't move on and don't finish the paper. So if it's something you find difficult to get your head around, move on, okay? Lots more questions. So anyway, we're going to work out what g of minus 2 is. So we get 5 minus 2 squared. Minus 2 squared is 4. 5 minus 4 is 1. And g of 1 is going to be 5 minus 1, which is 4. So if we think about the area that we're looking at, we're looking when x is minus 2. We've got, so x is minus 2, and then when x is 1, so let's put 1 here. So say this is 1, this bit here will be 4. And then if we've got minus 2, so that's over here. This bit here is 1. Okay. So the bit of the graph we're looking for is all of this. Now, what is the maximum in that bit for the y's? So if we have a look, the maximum for the y's is 5 and the smallest y is 1. So that 4, we didn't really need it. But at least we found out what it was, because if we had got confused, hopefully we'd see that we're going between the maximum, and the way that I got that 5 was I said this is minus x squared and I've shifted it up. Because remember, minus x squared looks like this. And then I've shifted this graph up by 5. The other way you could think about it is I could differentiate it, make it equal to 0, find my maximum point. But again, it's only 2 marks. So hopefully, if you see it's 2 marks, you know that it should be something relatively straightforward. And if it's a quadratic graph, you're thinking, what's the maximum, what's the minimum? Okay, so we've got g of x. We know we have to have it bigger than or equal to 1, but less than or equal to 5. Okay, we've tackled the horrible bit now. Now we get to do some of the nicer questions with functions. Okay, so we've got a function. We're told when x is less than minus 2. So we're finding minus 2. Oh, this scale's a bit strange. So I'm assuming it's here. So minus 2 on the x-axis. And I'm going up to, remember, fx is just like a y till 4. So this is what I want. And this is when x is less than minus 2. And I want my graph to go all the way to minus 4, which is here. So for this portion, this is my graph. Hopefully you can see that. Okay, now between minus 2 and 2, I've got x squared. So I'm saying to myself, well, x squared I know looks like this, but I've only got a little bit of it. So if I find out what 2 is, so minus 2 squared is 4, 2 squared is also 4, and because I know it goes to the origin, I'm just going to draw myself a curve. And I've ticked that one, done that one. Then the last one, we've got 12 minus 4x. We're expecting if we put 2 in, we're going to get 4. So 12 minus 8 is 4. And we want to go all the way till 4. So we're going to do 12 minus 4 times 4. So we've got 12 minus 16. And that's going to tell us our y-coordinate for the last point, which will be minus 4. So we've got 4 minus 4, which is over here. And with any straight line graph, you only need 2 coordinates because you join them up and you've got your straight line. And that is your 3 marks for that. Right, now it says use your graph to see how many solutions there are when fx equals 3. fx, fancy word for y. We find y equals 3. So if we take y equals 3, which is here, and all you're going to do is you're going to draw a line across and you're going to say how many times does it cross the graph. And we can see we've crossed 1, 2, 3. So my answer here is 3. Now it's saying solve fx equals minus 10. Now that we don't have minus 10 on this graph, but we know it's going to be somewhere down here, right? And this graph could keep going like this because this line here is for everything, all the x is bigger than 2. And if we were to do a line somewhere here, the only bit that would cross it would be this bit here. So the only thing that we are solving is we've just got 12 minus 4x, which is what that line bit was, equals minus 10. So we could do minus 4x equals, so you've got minus 4x equals minus 10 minus 12. So you're going to end up with minus 22, make them both positive, 22 divided by 4, well, 22 over 4. And in an exam, if they don't tell you to put it as a decimal, I'd leave it as a fraction. But if you wanted to and wrote 5.5, you'd also get full marks. Okay, simultaneous equations. Now, these are, well, we start off with the easy set, right? Which is sets of 2, which come up in GCSE, and we should be able to do it. We can either equate the coefficients or eliminate a variable. And then we're going to come to the 3 equations. Now, if it's in a calculator paper, you can test this using your polynomial and then simultaneous equation button. However, because they know a lot of you have the class whiz, it's unlikely to be worth a lot of marks if that's the case. So, when we solve simultaneous equations, we are finding where they intersect. So essentially, we're finding where the lines meet. If it was graphical, we would draw it and we would see where they meet. So, first step, we're going to put all the x's and the y's underneath each other. So I'm going to call that equation 1. I want to bring the x onto this side. So I'm going to get 3x plus 2y equals 13. Now, even though you might be able to see it, it's easier for you to do it like this because then you're not going to muddle up your x's and y's. Okay, so you're going to make one of them the same. So let me say we're going to make the x's the same. I'm going to times that by 3 and I'm going to times that one by 2. So my equation 1 becomes 3 times 2, so it becomes 6x plus 9y equals 33. And my equation 2 becomes 6x plus 4y equals 26. And now because the x's are the same, I can take them away from each other. 6x minus 6x disappears. 9y minus 4y is going to give me 5y. 33 minus 26 is going to give me 7. So y equals 7 over 5. And again, if you prefer decimals, you can write it as 1.4. And now we're going to sub back in. So I'm going to write sub in 1. So I'm going to get 2x plus 3 lots of 7 over 5 equals 11. So I'm assuming here it's non-calculator. It may be a calculator, but like I said, you know, I would be surprised if they did give you it in a non-calculator. So 21 over 5 equals 11. 2x equals 11 minus 21 over 5, which gives you 34 over 5. So x is 34 over 10, which could simplify down to 17 over 5. Okay, so we've got 7 over 5. Sorry, wrong way around. Don't make that mistake. So my x coordinate is 17 over 5 and my y coordinate is 7 over 5. Now, if you've done this and you've got 3.4 and 1.4, that's also perfectly okay. Whatever you're more comfortable working in. Okay, now comes the bit that's new for you, and that's having simultaneous equations with 3 bits in them. Okay, so let's have a look and let's think about how we're going to do these. So what we want to do is essentially we want to end up with exactly the same as what we do with normal equations, which is having essentially 2 simultaneous equations to calculate it from. So let's have a look. Right, there's a few ways you can substitute. You can look at what's the same and eliminate something and end up just with A's and B's. It honestly doesn't matter. I think sometimes the easiest way is to look for things that look obviously will be able to take away from each other. So I'm going to label them 1, 2, and 3. I can see if I do 1 plus 3, because can you see the C's are the same there, so they're going to cancel out. So if I do 1 plus 3, what am I going to get? I'm going to get 2a plus 6a, so I'm going to get 8a. b plus 3b, so 4b, equals 8 plus 0, which is just 8. And so I've got one equation. And then the next one, I want to get rid of the c from here. So I could do equation 2. I could take equation, let's do this actually. let's take equation 3. I just think adding is easier than taking away, then you're not thinking about the minus and the minus. And I'm going to multiply that by 2. So that gives me 12a plus 6b plus 2c equals 0. And if I rewrite equation 2 underneath, 3b minus 2c equals minus 9. What I can now do is add those two equations, and I end up with 16a plus 3b equals minus 9. So now I have two equations here. I've got two equations here with a and b as my unknowns. Right. So I could double this top equation. So let's call that 4 and 5. You don't need to number them. I think it just makes it easier for you to follow. So 4 times 2 is going to give me 16a plus 8b equals 16. And now I can take them away from each other. Right, so I can do 3 minus 8, which is going to give me minus 5b. And I've got minus 9 minus 16, which gives me minus 25. So I can see that b equals 5. Right, now I can find a. So I'm going to sub that into any of them. Let's sub that into number 4. So I'm going to get 8a plus 4 times 5 to give me 20 equals 8. So 8a equals 8 minus 20. Oops. So 8 minus 20 to give us minus 12. So a is going to be minus 1.5, so 3 over 2. Okay, so I've got both of them. I could plug them into any of the equations to find c. So let's say sub into 1. So I'm going to have 2 lots of a. I'm going to write it down here. 2 lots of minus 3 over 2 plus b, which was, what do we say? B was 5. Minus c equals 8. So we get minus 3 plus 5 minus c equals 8. And that's going to give you 5 minus 3, which gives you 2. So 2 minus c equals 8. So c must be minus 6. So your answers are minus 3 over 2, 5, and minus 6. There are loads of ways to do this. But essentially you want to eliminate something to end up with a simultaneous equation that you recognize. So you eliminate the same thing, but you have to use all 3 equations at some point. So one equation will use 2, and then the second batch uses the other 2. Find 2 of them, substitute it in to find the third. Okay. Completing the square. This comes up everywhere. And for those of you that are going to go on to do AS Maths, you never get to go away from completing the square. But there are 2 methods to do it. Let's go through the typical method. So, if I have ax squared plus bx plus c. So we do this with quadratics. Step 1, we want the x squared on its own. So we're going to take the a outside of a bracket. And when I do that, that one's going to be divided by a. But when I do this, I'm not going to take everything. Just going to take that bit there. And what I want to do with that is complete the square for that bit. Which means I take whatever's in front of the x and I half it. Alright, so I get x plus b over 2a, because I've halved it, squared. And then what I do is I minus that squared, whatever that value is. Okay, plus c. And if you're really interested, if you were to play around with this further, make it equal to 0 and rearrange it, you'll end up with the quadratic formula. So you'd have a b squared over 4a squared plus c. Okay, so that's all letters and it looks a bit strange. So let's do an example with numbers, which is exactly how you would do it. But before we do that, let me just show you why and how it works. So say I have x squared, we're just going to call that 2bx plus c because it's easier to see. Okay, x squared, essentially a box, x by x. Now remember, we split whatever's in front of the x by 2. So in this case, it becomes b. We minus the square and then add the c. So in this case, I'm going to get 2 rectangles. X is already there, so that's x by b, and that's x by b. Now to make that into a perfect square, I've got this extra b times b to give me b squared. But I don't want it because that's not part of my equation. So that's why I take it away and I add what's left there. Okay, don't worry about it too much. Let's look at it practically, and we're going to look at 2 methods. Method 1, take the 2 outside. So follow that thing. We've had lots of letters, might have been confusing. Let's do it with numbers. And we take that number out of the first 2. Okay, we then do like a bigger square bracket. And what I do is I take whatever is in front of the x and I half it. And then I take whatever number's here, doesn't matter whether it's positive or negative, inside the bracket, always minus 4 squared, which is 16, and put a big bracket round it. And so now when I open that, I've got 2 lots of x minus 4 squared, and then I've got 2 times minus 16, which gives me minus 32, and I can't forget my 13. And so that gives me x minus 4 squared plus 13, which gives you minus 19. And what does that tell you? So when you have a positive quadratic, when you complete the square, you end up with something like this. And that tells you your minimum is minus BC. So you change the sign of the thing in the bracket. See, and that tells you the bottom bit, that turning point at the bottom. If you've got a maximum, so a negative quadratic, it will be of this form, and your maximum will be minus CA. So your calculator will actually give you those numbers. So your number in front, so this A, is always the coefficient of the x squared. Doesn't matter what you do, it's always the coefficient. And then you can work out the min and max. Now, if you go blank in an exam, the alternative is to use that sort of matching method that we used. So we know A equals 2. So we're going to start off with saying, well, I know that A is always the coefficient of the x squared. So I've got 2x plus b squared plus c. If I open that out, squared plus c, I'm going to get 2x squared plus 4bx plus 2b squared plus c. And now I'm going to match things. So I can see that my 4b is the same as my minus 16, and everything else is equivalent to 13. So what does that leave me with? So it leaves me with minus 16 equals 4b. So b must be minus 4, which is what we got here. 2b squared plus c equals 13. I know that b is minus 4. Squared gives me 16. So I'll have 2 times 16 plus c equals 13. Rearranged is minus 19. So that is an alternative way if completing the square, I don't know, annoys you and you just really don't like it. Okay, so the next question is a little bit strange. We've got 12x squared minus 60x plus 5. We're going to approach it in exactly the same way that we approach it completing the square. So we're going to start off by taking 12 outside of the bracket of the first 2. We're then going to complete the square for this bit in the middle. But if you notice, you're going to get a fraction because you've got to half the minus 5. Okay, so now let's open that out. We're going to do 12 times all of this to give us 12x minus 5 over 2 squared. 12 divided by 4 is 3 times minus 25. It's going to give me minus 75 plus 5. So you're going to have 12x minus 5 over 2 squared minus 70. Okay, now if we look at the answer, that doesn't sort of correlate. So we're like, okay, something doesn't make sense here. So what we're going to do is the bit inside the bracket, we're going to put it one fraction. I'm going to put it all over 2. I'm going to get 2x minus 5 squared minus 70. So that's really like saying 12, 2x minus 5 squared, I can square the top and I can square the bottom. And now you can see you can do 12 divided by 4, which is going to give you 3, 2x minus 5 squared minus 70. Minus 70. And so you can see that your A is 3, your B is 2, your C is minus 5, and your D is minus 70. Okay, perfect. Thank you. I think that's right. Okay, proof. Everybody doesn't like this, but it actually is a really nice topic. You just need to know a few rules. So first of all, you need to know what an integer is. An integer is a whole number. So you may have to deal with integers. You may have to deal with natural numbers, which are counting numbers. And at that point, you can think about odd and even numbers. So if we think about it, what is an even number? An even number can always be written as 2n or 2x or 2 something. Now an odd number is always one more than an even number. So an odd number is going to be 2n plus 1. Okay, and if something is divisible by something, it means you can take that number outside of the bracket. So if I have a 5 outside of a bracket, it means the whole bracket is divisible by 5. So we've got now, show that all of this is divisible by 9, which means hopefully when we open out the brackets, we can take a 9 outside of it. Okay, how do we open out 2n plus 3 cubed? Now you could use your Pascal's triangle. Alternatively, you could do 2n plus 3 squared and multiply it by 2n plus 3. So we'll get 4n squared, 6 double 12n plus 9, multiplied by 2n plus 3. I'm doing this quite quickly. Obviously take your time and write it all out. And then you're going to have 4 times 2. So 2n squared. Yeah. So we're going 4 times 2 here. So we're going to get 8n cubed plus 36n squared plus 54n plus 27. Okay, then to that we're adding n cubed. So then we've got 2n plus 3 cubed plus n cubed. So you're going to get 9n cubed, 36n squared plus 54n plus 27. And then you can take 9 outside the bracket. 4n squared plus 6n plus 3. And you could write a concluding statement, or this would show it anyway. Therefore, that's what those 3 dots mean, divisible by 9. Right, next one. Prove that something is always bigger than 0. So let's just start off by opening it all out, because as it stands, it's not going to be something we can, again, I'm going to open it out quite quickly, pause this, try opening it out yourself and double check you get the same thing. So we're going to get 9x squared, and the way I do it quickly, just so you know, is take the first value, square it, 9x squared, times the 2 together, 3x times 5 gives me 15x, and double it. I get 30x plus 25 minus these 2 multiplied, 5x squared minus 50x. Okay, and when I simplify that, I'm going to get 4x squared, 30x minus 50x, so minus 20x plus 25. Now, if it is always bigger than or equal to 0, I'll be able to write it as an exact square term. So I'll be able to do something, something, all squared. Okay, so let's think about it. Take the first one, that's going to give you 2x. If you take the square root, that's going to give you 5. You want minus 20, so you can put minus there. And you could prove it to yourself by opening it out. And you can see that this is always bigger than or equal to 0 as square number. So whenever you want to prove something is bigger than 0, you've got to show it's a square number. The other method you could use is using the discriminant. Now the discriminant, if you remember, is b squared minus 4ac. In this question, a is 4, b is minus 20, and c is 25. So we get minus 20 squared minus 4 times 25. Okay? And you could calculate that. And if your answer would be, so let's work it out, we'll get 25 times 4 times 4, which is 400. 20 squared is 400, which is 0. And because there's only one root, which means it's bigger than 0. Because 20 squared is 400, so there's one root. So we know if we were to do the equation, it would be like this, and it would always be positive. Okay. Sequences, nth term and limiting value. Right, so this topic looks a little bit scary. You only really need to know the mechanics of it. You don't really need to, just gonna double check, I didn't miss a question, no. You don't really need to know exactly how it works, but it's good to know, right? So generally, if I take any value, what can I never, ever divide by? So I can never divide by 0. So I can never have 1 over 0. It's illegal. It doesn't work. Okay? So if I've got something with a 0 on the bottom, I know it's just gonna, because you can't do 1 divided by 0, right? It's gonna tend, what we say is it tends towards infinity because it's infinite. It goes up and up and up and up. Okay. And also, what else? So sequences, we talk about things tending towards things. A nice way to think about it is think about your 1 over x graph. If x gets bigger and bigger and bigger, so x is getting bigger, so it's going towards infinity, so it's getting bigger and bigger and bigger, y tends towards 0, because it tends towards our asymptote, but never ever reaches it. Okay, so let's think about a strategy of how we're going to approach this. Right, in terms, there's no limiting value in the first bit anyway, so it's saying the kth term, so instead of n, we're putting k of sequence A, so k 14k plus 30 is equal to putting k into sequence B. Okay, what we can do now, we're going to cross multiply. So that gets multiplied by that. So you get k squared equals 2 14k plus 30. Open it all out. We get k squared equals 28k plus 60. Move everything onto one side. And we have a quadratic. Now, if it's a calculator paper, use your calculator to help you factorize it. Although if we think about factors of 60, we could have, with a difference of 28, hopefully you're going to think, oh, it's not going to be a huge number. So it's not going to be like a long way down. So 60 and 1, we go, okay, we've got 60 and 1, that's not going to give me a difference of 28. 30 and 2, perfect. 32 minus plus. So then we end up with k equals minus 2 or k equals 30. Which one of those doesn't make sense? Can we have a minus term of a sequence? We can't we? So we've got the first term, then the second term, and the third term. We can never ever have a minus term. So we're going to cross that out, and we've got k equals 30. Okay, now we're going to look at the limiting value. So we're doing as n goes towards infinity. Right. One way to do this, remember if we have 1 over n, we can say it goes towards 0. So this is more so you understand it. You may have learned just to sort of cross out the ends. But what we're going to do is we're going to divide every single thing by n. So the top one's going to be 3n divided by n, 1 over n, because as long as we do something to everything, it makes sense. Now as n gets bigger and bigger and bigger, 1 over n goes towards 0. So then my whole thing must go towards minus 3 over 2, because the n's go towards 0. Right, work out the position of the term that has a value 0. Now remember, we can't divide by 0, but 0 can be divided by anything. So the top would have to equal 0 for that to happen. So 5n would be 1420. Okay, so n equals 1420 over 5. We could double both of them and then divide by 10. So you could see it's actually double that. So 284. And now we've got to think about the limiting sequence. And now let's do it in that same way. So we're going to make sure we end up with divide everything by n. So we get 1420 over n minus 5 over 1420 over n plus 5. So as n goes to infinity, 1420 over n goes to 0, which leaves you with minus 5 over 5, which is minus 1. So your answer is minus 1. Okay, I'm trying to go through this at some sort of speed so we get through it, and you've also, otherwise you'll be listening to me for hours. We've now got the factor theorem. Now, what does the factor theorem say? So the factor theorem tells us that if we substitute a number in, so if f of any value equals 0, then x minus a must be a factor, must be one of our brackets. So your first step is always to take what you've been given and make that equal to 0. So as if you were solving it for the roots. So when we do that, we get x equals minus a third. So this tells us f of minus a third should be 0. Now, it's telling us it's a factor. In order to do this in an exam, all you're going to do is write this out as if you'd put it into your calculator. So I'm putting minus a third in everywhere, and I'm going to say that equals 0. Okay? Now, you need to show all four terms. You need to show this line, but you don't necessarily need to show yourself opening it out. And now it's telling you to factorize fully. Now, you may have learnt this in a few ways. You may have done a long division. You may have also done like it by inspection. I do long division slightly differently to like the linear form because I think it's easier. Let me show you what I mean. So I've got a cubic. I'm going to take my factor and I'm going to write it 3 times. And then I'm going to take, so let me write the equation here. So it's just above. And I'm going to say, what do I multiply this by to get this? So I need to multiply 3x by x squared. So I'm going to put x squared there, and I'm going to open out those brackets. So I'm going to get 3x cubed plus x squared. So now I have x squared, but I want minus 2x squared. Okay? And I also know that I'm going to be multiplying it by that. So I'm going to say, okay, I have x squared, I want minus 2x squared, so I need to take away an extra 3x squared. So I'm going to have a minus x here, because when I open out this bracket, I get minus 3x squared minus x. So now I have a minus x, but I want minus 7x. So I need to have an additional minus 6. So that's going to be a minus 2 here. So I'll get minus 6x minus 2. Everything beautifully balances. This tells me I've got 3x plus 1 x squared minus x minus 2. And then I can factorize it again. And I get x plus 1, x minus 2. Now, if you've learned it going down and that makes more sense to you, just do it that same method, okay? This is just alternative. The other way that you can factorize when you've got a factor is you say 3x plus 1 is something squared plus something plus something. And you sort of match your coefficients. So you say, well, we can see a has to be 1. So you can do the first and the last really easily. And c is minus 2. And you could open it out, plugging those in, and choose either the minus 2 or minus 7 and get your b. There's lots of different methods. Stick to the one that makes sense to you, that either you've learnt or makes sense. Okay, next question. Very similar, they're all going to look the same if they're like this. So let's use that same method. I'm going to do x minus 2 equals 0. So x is 2. And then we're just going to say f of 2 equals 2 cubed plus 8, 2 squared plus 5, 2 minus 50 equals 0. And that's it. Okay? Now we want to factorize. Okay, so I'm going to show you the method I talked about at the end. We're going to do this multiplied by some ax squared plus bx plus c. This is the only place I can get x cubed. So I can say a equals 1. The only time you get your 50 or your constant is the last two. So minus 2 times something gives me minus 50. So that something must be, I want it to become a minus, so it must be plus 25. Okay, so now I can choose any of the others. So let's say, how do I get x squared? Well, that's going to give me x cubed. That's going to give me x squared. So if I do bx squared, that term, that's going to give me just x. These two are also going to give me x squared, minus 2a x squared. So I can see b minus 2a has to equal 8. I already know what a is, so b minus 2 equals 8, so b is 10. So now I can see I have x minus 2, and I've got x squared, b was 10, plus 10x, plus 25. And then I can factorize that entirely. Hopefully you can see that. That's the same as x plus 5 all squared. First things first, we're going to look at equation of a line. So we know that an equation of the line is in the form y equals mx plus c. M is your gradient. So this tells you about your slope. So it's going to be positive or negative depending on whether you're sloping up or down. The higher the number, the steeper the slope. Plus c is your y-intercept. Now your y-intercept is when x is 0, what is y? So it's where you cross that vertical axis. There's a few equations that we need to know. Our gradient is our y2 minus y1 over x2 minus x1. You might have done it as rise over run, change in y over change in x. That's all this is, but in equation form. And an equation of a line, we learn a new way to write it. You can always substitute your gradient and your points in and find your plus c. But this just makes it easier. So in further maths, we find this easy way to find an equation of a line. Right, let's look at some questions. So we're given a straight line passes through some points. We want to work out the equation. Step 1, I'm going to find the gradient. So I'm going to say my m is, let's label these, x2, y2. So y2 minus y1 over x2 minus x1. So we get minus minus, so that's going to become a plus. So we've got minus 9 over 3, so we've got minus 3. Now I'm going to use that equation. Y minus y1, and I can use either of the points. Just going to use the first one. No reason why. Actually, it might have been easier to use the second one. So then my mx minus x1. You open that out, we get y minus 11 equals, now this is going to make a plus, minus 3x, minus 3 times 2, so minus 6. So y equals minus 3x minus 6 plus 11, so we end up with plus 5. So y equals minus 3x plus 5. Okay, next one. We've got points with a gradient again. We're looking at gradients. So x1, y1, x2, y2. We're going to get our gradient, which is going to be y2 minus y1 equals x2, which is a, minus x1, which in this case is minus 3. And we know that equals 12. So we get b plus 10 over a plus 3 equals 12. Okay, let's multiply this bit underneath up here. So we're going to get 12 times a to give us 12a, 12 times 3 to give us 36. And what we want to do is, I think it's quite easy to find an expression for b here. So we'll get 12a plus 26, and then we can just substitute values in. It says integer values, so we want whole numbers. So pick a number. I'm going to say if a is 1, it's probably the easiest one. B is going to be 12 times 1, 12 plus 26, which is 38. So here's an example. You could have chosen 0 and you'd have got 0 and 26, or anything like that. It's only 2 marks, even if they've left us a lot of space, but that's all we need to do there. Okay, so now we're going to look at a midpoint of a line, or somewhere along the line, not necessarily the midpoint. If it was exactly the middle, if we have 2 coordinates, to find a point exactly in the middle of those, you add up the x's, you divide it by 2. You add up the y's, and you divide it by 2. And that would give you a coordinate of exactly halfway. Or you could say, how much have I moved up and down, and split that. And that's what we're going to be doing here. So we know that this is split in the ratio 5 to 2. Right, what we're going to do first is find our differences. So how do we go from 5, how do we go from 3 to 5? We're going across 2. And then if we want to go from 7 to 5.5, we're going down 1.5. So we're just looking at how much each bit of the space is. Now, this 2, if you like, is worth 5 bits, and we want to work out how much 2 bits are. So we're going to take that 2, divide by 5, and then times by 2, which will give us 4 over 5, which is 0.8. So now I know that across here, I've got 0.8. Now, for the 1.5, we're going to do exactly the same. Now, because I'm going to assume it's if it was in a non-calculator, dealing with fractions is a bit easier. So I want to divide by 5, and I want to times by 2. So that's going to give me 3 over 2 times by 1 over 5 times 2. And when I do that, I end up with, well, that cancels, and I end up with 3/5, so 0.6. So I know this bit is going to be changed by 0.6. So now I'm saying my 5, I'm going along an additional 0.8. So 5 plus 0.8 is going to give me 5.8. And 5.5, I'm going down by 0.6. So 5.5 minus 0.5 will take me to 5, minus that extra 0.1 is going to take me to 4.9. And that's me splitting that line up, just thinking about the ratios. Okay. Now we get to use our midpoint. So we get told M is actually the midpoint of the line AB. So we know this is our x1, y1, x2, y2. So I know if I add up minus 2 plus 7 and divide it by 2, I'm going to get P. And 3 plus R divided by 2 is going to give us minus 1. Okay, so from the first equation, we can see that minus 2 plus 7 is going to give us 2P. So 5 equals 2p, so p must be 5 over 2, or 2.5, depending on whether you like to write them as decimals. And then r is going to be 3 plus r equals minus 2. So then we're just going to say, well, r must therefore be minus 2 minus 3. So we get minus 5. Okay. The next topic is looking at the intercept of a line. So that's where something crosses an axis. So actually, let's have a look. There's lots of different types of intercepts. So if we take an equation, let me take a purple line here, and let's draw a blue line like that. Okay, so let's look at some coordinates. This here is where the purple line intercepts the y-axis. It's my y-intercept. So this would be 0, and it would be some y coordinate. Sub-0, y1, let's say. And this as well would be a y-intercept. Here is where the blue line, so I know the purple line even, crosses the x-axis. And at that point there, that's an x coordinate and the y is 0. And where two lines meet, that's also called an intersection. So you've got to really think, like if they say, what is the intersect of the x? People normally immediately put x is 0. That's wrong. It's y is 0. So when you intercept the y-axis, x equals 0. And when you intercept the x-axis is when y equals 0. Okay, let's have a look at some questions. So we've got L is a straight line. At which point does it intersect the x-axis? So intersecting the x-axis means y equals 0. So when all of these y equals 0, but I'm going to make y equal to 0. So ax, b times 0 is just 0. So ax equals c. So therefore x must be c divided by a. So my answer would be here. Right. What is the gradient of a line parallel? Okay, when two things are parallel, their gradient is exactly the same. So if we have this, I can't see what the gradient is yet because I need it to be y equals mx plus c. So to find the gradient, I'm going to rearrange it to make y the subject of the formula. So I'm bringing the ax to the other side, becomes minus ax plus c. And now to divide by b. So putting everything over b, I can put each bit individually over b. And now hopefully you can see that this bit here is your gradient. If I compare it to the options, it's going to be that one there. Okay, now they've got work out the point of intersection of the lines. Okay, so we've got simultaneous equations again, just in context. It's what we use them for. So we've got 2x plus 3y equals 11. I'm going to bring that 3x over, and we get 3x plus 2y equals 13. We want either the x's or the y's to be the same, so I'm going to make the x's the same. I'm going to times this one by 3 and this one by 2. So I'm going to get 6x plus 9y equals 33, and 6x plus 4y equals 26. So that's my 1 and my 2, that's my new 1, my new 2. I can take them away from each other. 9 minus 4 gives me 5y, that gives me 5y equals 7, so y is 7 over 5. I substitute it back in, so I might want to write that as 1.4, and I substitute it back in and get 3.4. If you want to go through this slowly, we've done it in the algebra section. There was the exact same intersection question when we were talking about simultaneous equations. Okay, now we've got equations of 3 lines. The lines intersect at the points O, A, and B, as shown in the sketch. Show that the length of OB, so let's find the length OB, So let's take OB, which is here, is equal to the length AB. So we're saying this yellow line is equal to that. Right, how are we going to go about doing that? We've been given the equations. We first need to identify, well, no, they've told us which one is which. Okay, so we need to identify some coordinates. If I want to find out the distance, the first thing I'm going to have to do is I'm going to have to work out the coordinate here and the coordinate here. Okay, so the coordinate of B is when 2x meets this graph here. So we've got 2y equals 11x minus 7 and y equals 2x. So this is easy because you've already got y equals something. You can just substitute the 2x. So the whole of the 2x can go into the y. So we get 2 lots of 2x equals 11x minus 7. 4x equals 11x minus 7. So we end up with 7x, 11 equals 7, so x is 1. Now if x is 1, y must be 2. So we know this coordinate here is 1, so 2 times 1 is 2, 1, 2. Okay, which makes sense, it's in the positive axes, so we're all good here. Right, now let's find A. A is when this line here, which is this, meets this line here, which is this. So let's solve those two simultaneously. So we're going to have 2y equals 11x minus 7 and x plus 3y equals 0. Okay, so again a substitution might be easier because we can take this and just move that 3y. So x equals minus 3y. So we get 2y equals 11 lots of minus 3y minus 7. So 2y equals minus 33y minus 7. Add that onto that side. So we get 35y equals minus 7. So y equals minus 7 divided by 35, which is going to give you minus a fifth, which is minus 0.2. Then we can sub it back into here. Minus and minus make a plus, so plus 0.6. So this is going to become plus 0.6 minus 0.2. Right, so now we've got our points. We want to find the distance of OB, left space there. So the distance of O to B, and we're going to find the distance of A to B. Okay, O to B, let's think about this. That's our coordinate, is 1, 2. So all we're doing is the change in y, so you're drawing a triangle, because you're looking at how much different it is. So from 2 to 0 is 2 and 1. So O to B is going to be Pythagoras of 2 squared plus 1 squared. So I'm just going to leave it as square root 5. A to B is going to be your change in the x's squared minus the change in y. So let's think about a generalized difference between 2 points. It's always going to be x2 minus x1 squared, y2 minus y1 squared, and the whole thing square rooted. So in this case, we're going from A to B. So we've got 1 minus 0.6 squared plus 2 minus 0.2 squared. And then when we stick that into our calculator, this is calculator paper, we get root 5. And then we'll just say OB equals AB. So that shows how you find the length or the distance between 2 points. But it's mainly surrounding the intersection of them as well. Okay, parallel lines. We talked about this briefly when we came up with the question, but parallel lines are lines with the same gradient. So it's when the m are exactly the same. So y equals 7x plus 4 is parallel to 7x minus 3004. Doesn't matter what the plus c is. The bit we're concerned with is the gradient, which is the bit in front of the x. Okay, here we go, saying write an equation that is parallel to this. we've got a problem. We don't know what the m is because we need y equals. So we're going to divide both sides by 2. So we get y equals a half x. So we know the gradient will be a half. So we've got y equals a half x plus some c. We know when x is 4, y is 0. Don't be tempted to sub in c is 4 because it's the other way around. So let's substitute it in. So when x is 4, y is 0. A half times 4. So 4 divided by 2 is 2. So c must be minus 2. So my equation is y equals a half x minus 2. Actually, let's write that a bit neater. So we've got y equals a half x minus 2. Okay, so I hope that makes some sense. Right, now we've got a quadrilateral. What does that mean? So all a quadrilateral is essentially a four-sided shape. We're told that M is the midpoint of PS. Okay, well, we can find M. We know how to do that, don't we? We add the x coordinates, so 6 and 4, and we divide by 2. And we add the y coordinates, and we divide by 2. So when we do that, we get a P and S, yeah. So when we add the x coordinates, we've got 6 plus 4, which gives us 10 divided by 2 is 5. So that must be 5. 11 plus 1, which is 12, divided by 2, which is 6. So we've got 5, 6 as our midpoints. We want to use the gradients to show that MR is parallel to PQ. Okay, so we're going to find the gradient for each bit. Right, so let's do PQ first. So PQ. So for PQ, if I do x1, y1, x2, y2, and I'm going to take away. So we're going to do minus 3 minus 1 over 10 minus 4. Now, if you look at the slope, you're expecting a negative slope. I've got minus 4 over 6, which is minus 2 over 3. Okay, so that's the gradient of PQ. If I want, I could put an M here or even write gradient. And now I want a gradient of MR. So for M to R. So I'm looking for this one here. Okay. And I'm going to do exactly the same thing, right? And I'm trying to show that they're parallel. So I want to show my change in y over my change in x is exactly the same. So if I do 0 minus 6 over 14 minus 5, I've got minus 6, and then 14 take away 5 is 9. That also cancels down to minus 2 over 3. And so you're going to say MPQ equals MMR, therefore parallel. And you've shown your work and got your marks. And I think this question in total was, it's just 3 marks. Well, still, it was still 3 marks. Okay, next question. We've got a point on a circle and the equation of a circle. Okay, so what is the general equation for a circle? So your general equation for a circle is x squared plus y squared equals r squared. And that tells you that the center is 0, 0, and the radius is r. However, that center could shift. If it shifts, instead of x, it's x plus, remember x's do the wrong thing, so x plus 1 if it shifted to the left on the x coordinate, or if it shifted to the right. Okay. And every single point around the whole curve will satisfy that equation. Okay, let's show you what that means. So we've got an equation here. We've got x squared plus y squared equals 29. So that's saying the center is 0, 0, and the radius will be root 29. Okay, so that's what my equation is saying. And I want to show that P is on the circle. So I have my circle, I have my center, and I know this coordinate here is somewhere on the circle, which means it satisfies this equation. This is the x, this is the y. So I've got minus 5 squared plus 2 squared gives me 25 plus 4, which equals 29. So therefore I have shown that it satisfies that equation. It really is that straightforward. Okay, now what did we say? Sometimes the center shifts. And when it does, we have x minus a squared, y minus b squared equals r squared. And that's when the center isn't quite 0, 0. Right, so we've got a circle center C, and it touches the y-axis at the point 0, 2. And the line y equals k intersects the circle at 1k and 5k. And we've got to work out an equation of the line. So we need to work out how far in and out the line is. So what the center is and what the radius is. Okay, so if we're going to go from the center to the edge, we've got this line here, we can see that we're going from, this is 0 to some point here. How am I going to find that point? So if I have a look, I've got these two bits that cut it across. That's called cutting a chord. So if I draw a line up here, this gives me a radius as well. So does this. But if I go halfway, I'm going to cut this exactly in half. Okay. Right. Now remember, the general equation is going to be x minus a squared plus y minus b squared equals r squared. So all I know at the moment is that my center is in line with y equals 2, so I know the y coordinate of my center is 2. Okay, so that I can see really clearly. Right, I also can see my x coordinate, because if x is 1 here and x is 5 here, and this cuts it right in the middle, my x coordinate must be the middle of 1 and 5. So 1 plus 5 is 6, divided by 2 is 3. So I get x minus 3 squared equals r squared. And remember, every point along the circle satisfies that equation. So I'm going to substitute this point in. So I'm going to get 0 minus 3 squared plus 2 minus 2 squared equals r squared. So you're going to get r squared equals 9. And so my final equation is going to be x minus 3 squared plus y minus 2 squared equals 9, which I could have seen because I know that the x goes all the way out. Right, let's have a look at the next equation. So we have two circles, each with a center 0 as shown. Okay. Work out the perimeter of the shaded section ABCD. Okay, so we've got a quarter of a circle that's been shaded. So let's have a look at what we're going to do with this. So first of all, we can use these equations to tell us the radius. So the radius of one of them is going to be the square root, because remember we've got x squared plus y squared equals r squared. So the square root of 289, so here the radius is 17, and here the radius, you hopefully recognize, is 11. So we know this space is 11, okay, and we know all of this is 17. Now the bit that's shaded is the big circle minus the small circle, okay? But in terms of perimeter, we're not looking for the area, we're looking for the perimeter. So we're looking for this bit this bit, and then these 2 bits. So the easy bits are the 2 bits that we can find. So this is 6, and this is 6. This bit here is part of the circumference. So if you remember, the formula for circumference is 2 pi r. So if I say small circle is going to be 2 times pi times 11, but I've only got a quarter of it. So I'm going to divide that by 4. Okay? Right, and the large circle is going to be 2 times pi times 17 divided by 4. So when I add those up, work them out, so I get 2 times, it's a calculator, divided by 4 gives me, it doesn't say how many decimal places. Okay, so we can leave it as 5.5 pi, and 2 times pi times 17. So 17 times 2 divided by 4 gives us 8.5 pi. So we're going to get 8.5 plus 5.5, so 14 pi plus 12. Now, if it was a calculator paper and they may have asked for it in terms of decimal places, if this was the case, then you would just substitute in to 3 significant figures. Here, because it's not clear, you could do any one that you liked. Okay. All right, so now we've got an equation of a circle, and this one's a little bit trickier. So if you have a look, you've got x's and y's, and they've all shifted. So it's not quite x squared plus y squared. What you're going to do is you're going to take your x squared section, and you're going to complete the square. And you're going to take your y squared minus 6y and complete the square for y. So half what's in front of the y, square it and take it away. Now we're going to put it all together. Equals 0. We can move the numbers onto the opposite side. And remember, x minus a squared plus y minus b squared equals r squared. AB is your center and r is your radius. So here we can see straight away that our center is 1, 3, and our radius is root 10. Okay, so now we're almost there. We're looking at the equation of a tangent to a circle. So those of you doing Edexcel GCSE, they've also on the advanced information explicitly said this is actually going to be in the GCSE specification as well. That should really be a straight line. I don't think I've drawn it very straight. Let's try again. So, okay, let's draw that as a tangent. So that's just meeting at one point. Okay, so from the center to a tangent, we know we get a right angle. So if this is my AB, and if we let's call this XY, the gradient from AB to your X1, Y1 is going to be perpendicular to the gradient of the tangent. Okay, let's work through an example, and that's going to make more sense. So we've got a circle. So we're given a circle here, and we're given a point. So let's draw the tangent here as well, because I know I'm going to need it. Okay, so we've got a circle, center 0, 0, because it's just x squared plus y squared. And there's a point here, which is minus 5, 2. We want to find the equation of the tangent to be able to find where it meets the axes. Okay, so step 1, we're going to find a gradient. So we're going to find the gradient of this line here to start with. So we've got our change in y over our change in x. So if we have a look here, we can say so it depends. Like I said, we can use y1 and y2. We can do our rise over run. It doesn't really matter. So we've got our m, which will be minus 5 minus 0 over 2 minus 0, so minus 5 over 2. Okay. And we sense check, is it negative? Yes, we've done that right. Now the tangent is the inverse reciprocal, which means you flip it and you change the sign. So if that's the m of the radius to the point, then m of the tangent is 2/5. Now we know p is on that line. So we can use y minus y1 equals m x minus minus 5. Right, so we've got y minus 2, and this is where this equation comes useful. We don't need to rearrange it. We just want to find out where it intersects the x-axis. So it intersects the x-axis when y equals 0. So when y is 0, we get 0 minus 2 equals 2/5 x plus 5. So x plus 5 equals minus 2 times 5 divided by 2. So minus 5. Minus 5. So x equals minus 10. So your x coordinate will be minus 10. Okay, let's have a look at the next one. So we've got another one. We've got a circle C as an equation, and P and Q are points on the circle. The tangent at Q is parallel to the x-axis. The tangent of P and Q is set. Okay, write down the coordinates of C. Okay, so that one's easy. So remember our equation, x minus a squared plus y minus b squared equals r squared. So if that's 1, our x coordinate is 1. This is plus 3, so our y coordinate is minus 3. Okay. Show that the equation of the tangent is y equals 2. Right, so we want to know from here to here, if the radius, so remember r squared, so if we know r squared equals 25, r must be 5. So if this is 1 minus 3, and this is 5, minus 3 plus 5 equals 2, therefore y equals 2. So we're going straight up by 2. Okay, nice. Work out the x coordinate of r. Okay, so we want to work out this coordinate here, which means we need to work out the equation of this line. To do that, we first need to know the equation of, or the gradient of this line. So we want to know the gradient of the line from C to P. Okay, how are we going to do that? We do our y1 minus y2 minus y1 over x2 minus x1. So we want this equation here. So if we have a look from minus 3, so from minus 3 to minus 7, so if you think about that, that space is 4, and from 1 to 4 it's 3. So, and it's a negative line, so we've got minus 4/3. And we've got the 4 minus 7. Okay, so we've got 4 minus 7 as our thing, and our m of C to P is minus 4/3. So therefore, the gradient of the tangent is the inverse reciprocal. Remember, flip and change the sign. So 3/4. So we do y minus y1 equals m x minus x1. And we're trying to find out where that meets this line here, which we know is the line of y equals 2. So we substitute in, y is 2. So we get 2 plus 7 equals 3/4 x minus 3. So 2 plus 7 plus 3 gives us 12 equals 3/4 x. So x is going to be 16. The x coordinate is 16. The first bit of this topic is about rate of change. Now, essentially, it's a fancy way of talking about the gradient. So dy dx, which we know as the gradient function. But essentially, It's your change in y over your change in x, which is, when you have a straight line, for example, how you work out the gradient. So it's how something changes with respect to something else. So we've got a grid, we've got to sketch a graph, a rate of change of y with respect to x is always 0. So essentially, when is a gradient 0? Now that's going to happen when you just get a horizontal straight line. So as you change the x coordinate, the y coordinate doesn't change. So we end up with a horizontal straight line. It says on the graph, the rate of change is always positive. So here, what we need is a straight line just with a gradient of 0. And it doesn't matter, it doesn't need to go through 0, 0. We're not talking about directly proportional. It just needs to be a positive straight line. Might as well do it through 0, 0, but there's no reason to. Okay, now we've got 5 graphs. And the question asks us different things about it. So the first bit is the rate of change is always negative. So that means it's always negative, so it's always going to be sloping downwards no matter which point we look at. So if we have a look, that's going to be graph C. So graph C, we know, is always negative. Okay, the next bit says is always 0. So exactly like we just drew the other one, we're essentially looking for a horizontal straight line. So we've got this one here. So this is always 0. And the last bit says, as x increases, the rate of y with respect to x decreases. So we're saying as x goes up, right, the rate of y decreases, so the gradient decreases. Now when we've got a curve and we want to think about the gradient, we're just going to think about the tangent at lots of different points. Now if we have a look, we start off with a steep line over here, and it's less steep and less steep. So the answer here would be A. Right, next bit is differentiation. And this is quite a nice topic because all you do is when you have something to differentiate, so you'll have y equals x to the power, let's put a number in front, so k x to the n. dy dx, all you do is you bring that number down and you multiply by that power. And then you take 1 away from the power. So you multiply by the power and you reduce the power by power and you reduce the power by 1. So with this question here, we've got 2x to the 10 minus 3 over x squared. So before we can start to do this, our first step is going to be to rewrite this indice in a way that's easy for us to differentiate. So we've got 2x to the 10. Now because it's on the denominator, we're going to bring it up. And when we do so, that 2 becomes a minus 2. So now when we do dy dx, we multiply by the power 2 times 10 to give us 20x to the 9. And then we bring down this one. So minus 3 times minus 2, which is plus 6x, minus 2 minus 1 gives us minus 3. So be super careful with negative numbers. We've got some more here. Now when we've got something with something on the denominator, we want to be able to split it out. So we split the numerator. So this is the same as saying 2x to the 7 over 3x plus 15x squared over 3x. So if we take the first bit, we'll get 2 over 3. And we can cancel down. So we've got x to the 7 divided by x. Now remember, when we divide indices, we're taking away. So we get x to the 6. 15 divided by 3 gives us 5. And then x squared divided by x 2 take away 1 is x. Now we're going to differentiate it. So remember, we multiply by the power, 6 times 2, giving us 12. Divide by 3 is going to give you 4. So we're going to end up with 4x to the 5 plus 5. Because remember, 5x, the gradient of y equals 5x, is just 5. So we want to know what that equals, what x equals when all of it equals 133. So I can take away 5 from both sides. 133 take away 5 is going to give me 128. If I then divide by 4, 12 divided by 4 gives me 3, 8 divided by 4 gives me 2. And you should know that the 5th root of 32 is 2. So your answer is 2. Next bit says, work out the rate of change of y with respect to x at a certain point. Now remember, rate of change, just a fancy way to say differentiate. So step 1, we're going to open out those brackets. X squared times x squared is going to give us x to the power of 4 minus 9x squared. And now we're going to differentiate it because they've asked us for the rate of change, which essentially means that they want you to differentiate it. So when we differentiate that, we multiply by the power, so bring that in front, reduce the power by 1, 4 take away 1 is 3, same here, minus 18x. And now we're saying when x equals minus 2, what does dy dx equal? So we're going to get 4 times by minus 2 cubed minus 18 times minus 2. So 2 cubed is 8. So we've got minus 8 times 4 to give me minus 32. 18 times minus 2 is minus 36. Minus and a minus make a plus. 36 minus 32 to give me 4. Okay, the next bit, we're looking at the gradient of a curve. Now, exactly the same. Rate of change, gradient, all of these things are different ways when we talk about dy dx. So when we think about a curve, so any curve at all, if I take a random curve, if I wanted to know what the gradient was there, I would have, in GCSE, you draw a tangent, you'd find change in y over change in x. That's all dy dx is telling you. It's giving you, if you substitute the x in, what the gradient will be at each of those different places. Okay, so let's take this first one. We've got work out the gradient when x is minus 1. It's given us dy dx. So essentially, all we're going to do is substitute in some values. So when we substitute our values in, we've got 9 minus 1 cubed. Now, even though you might be able to do that really quickly in your head, just write it out. You know, 9 minus 9 plus 1, so the answer is 10, just to avoid making any silly mistakes. Right, work out the value where the rate of change of y with respect to x is 1. Again, rate of change, same as dy dx. So we've got 9 minus x cubed equals 1. X cubed is going to equal 8. So x must be 2. Because the cube root of 8 is 2. Right, slightly longer question here. We've got a curve has an equation. The gradient, we see gradient, my brain's going to go dy dx. So first let's just work out dy dx. Bring the number down, the power down, and take 1 away. So we get 3x squared plus 2ax. Now we're saying when x equals 4, what is dy dx? So when x equals 4, dy dx is going to be 3 times 4 squared plus 2 times a times 4. So that's going to give us 4 squared, 16, times 3, so 48. 2 times 4 is 8, so 48 plus 8a. Okay. And when x equals minus 1, dy dx is going to be 3 minus 1 squared plus 2 times a times minus 1. So we're left with minus 1 squared, which is just 1, times 3, plus, well, it's going to actually give me a minus 2a. And now what does the question say? The one, when x equals 4, is twice x equals 1. So that tells us 48 plus 8a is twice, so 2 lots of 3 minus 2a. So when we open out those brackets, we've got 6 minus 4a. Put all the a's on one side. So you're going to get 8 plus 4, so 12a. And then you're going to have 6 minus 48. So you get minus 42. Divide them and you've got minus 3.5. So your answer would be minus 3.5. And that's 5 marks. It's quite a lot of marks. And you just follow that process. Okay, so we've got a curve, y equals fx. dy dx has given us what dy dx is. When x equals minus 2, the gradient is 12. Okay, so we're going to substitute in x is minus 2. So when x is minus 2, dy dx is going to be 3 over 2 times by minus 2 minus k times minus 2 to the power of 4 plus k. And we know all of that equals 12. So now if we sort that out, we've got minus 2 is going to cancel there. We're going to get minus 3. Minus 2 to the power of 4, giving us 16. So we've got minus 16k plus k equals 12. Move the k's onto one side. We're going to get 15k equals, so if we move the k's onto there, we got minus 3 minus 12, so we've got minus 15, so k must equal minus 1. And you may rearrange that differently, but you should get the same answer. So now we're going to think about what stationary points are. So stationary points are where you have a minimum or you have a maximum. So, for example, if I have a quadratic, think about a quadratic, and I have a positive quadratic, this has a minimum point. So there's a point at which it's the lowest. Now if we have a look, the gradient just before that is negative and just after it is positive. So what happens is you get your turning point just before it. In this case it's negative and then it'll be positive. So when you have a stationary point, you're always going to get also a change in the gradient either side of it. So here we've got a maximum, and in this case just before it's positive and just after it's negative. You can also get what's called a point of inflection. Now this one's a bit more special, right? The gradient just before is positive, but so is the gradient afterwards, right? And it doesn't matter, you could draw it the other way around, at which point you'd get it negative followed by a negative. So there's 3 types of stationary points: your minimum, your maximum, and your point of inflection. So maybe what we do, if we write here, gradient just before and then just after will be different. So in this first example, just before it's negative, and just after is positive. So we see a change in gradient. In this one here, it's positive and then it's negative. And at the point of inflection, it's the same. So it's positive, and it's negative and negative. But at the actual point, so at the actual point of either inflection or minimum and max, dy dx is always 0. So at a turning point, which is sometimes called a stationary point, so it's where the curve changes direction, it's going to be the case. Right, so we've got show that we've got a curve has exactly 2 stationary points. So step 1, we're going to be differentiating it. So you see stationary points, you see turning points, your brain's going to go differentiate. Okay, so we bring the power down and take 1 away. And when we do that, we get 3x to the 4 plus 4x cubed. And now, at the stationary point, we know all of this equals 0. Right, what can we take outside the bracket? We can take an x cubed outside the bracket, giving us 3x plus 4. And then we can see x equals 0 or x equals minus 4 over 3. And we've shown our exactly 2. So we've got exactly 2 answers. Okay, we've got the curve y equals fx, has dy dx, long thing. It has 1 stationary point when x equals minus 2. And we want to show it's a point of inflection. Okay, so first of all, if x equals minus 2 and it's a stationary point, then dy dx must be 0. So we're going to say when x equals minus 2, dy dx equals minus 2 plus 2, minus 2 plus 2, both of those brackets become 0, equals 0. Okay, so we've shown that there is a point there. Now what we want to do is we want to take a point either side of it, right? So, and because it's a point of inflection, we should find the value stays exactly the same. So let's take x equals, when x equals, let's say when x equals minus 3. So it's smaller than minus 2. So when x equals minus 3, dy dx equals minus 3 plus 2 to the 6, minus 3 plus 2 to the 4. So we're going to end up with 2 minus 1 to the 6, which is just 1, and plus 1 and plus 1, which equals 2, which is positive. So the gradient to the left is positive. Right, let's say we take 1 to the right. So let's say when x equals minus 1, dy dx is going to give us minus 1 plus 2 to the 6, plus minus 1 plus 2 to the 4, which is going to give you 2 minus 1, which is 1, 1 to the 6, which is 1, plus 1, which equals 2, which is also positive. Right? And we could say as both the gradient, as gradient before and after, right, the same, this is a point of inflection. And that would be your method to do that. There's some other methods you could use, but I think this one makes the most sense. Okay. So, I've got one more question here for this section. We've got the continuous curve y equals fx has 2 stationary points, and it tells us a little bit about them. Now we want to know where is the stationary point. Now we know that happens when dy dx is 0. So straight away we can hopefully see it's when x equals minus 1 and when x equals 2. Oh, okay, so we're still part of the same question. This makes more sense. And we want to find it is giving us the y values. So 3 and 1. And we want to find out whether it's a maximum or a minimum. Now remember, when you have a minimum point before it, you have a gradient that goes negative, and after you've got a positive gradient. When you've got a maximum point before it, your gradient is positive, and after it, it is negative. So if we take that -1, before is positive, after is negative. So it must be a maximum. For the 2, before is negative, and after in this case is not either of these, so it's not a minimum. So it must be that point of inflection. And it's not part of a different question. The same question is part of a totally different question. I hadn't seen the f-1 and f2. Okay, next bit. Matrix multiplications. I know I'm talking fast, but please, make sure you pause this video, go back over it. It's just so if there's only certain questions you got wrong, you can sort of zoom through them. When we multiply matrices, you do each row of the first matrix multiplied by each column. So your fingers do that. So you go along and down. Okay. So if I was to so everything is pairwise. Now, when we multiply a matrix, it goes on the front. So if you do A multiplied by B, it's BA, not AB. So each row is multiplied by each column. Now this will make more sense when we have a look at a question. But also remember that your calculator, if it's in the calculator paper, I know that's after half term and it's still a little bit a while away, well after half term. So if it's in the calculator, you can use your calculator to multiply them, but they'll be worth a lot less marks. Okay, so we've got AB equals C, right? So now A is a 2 by 2 because you've got 2 rows and 2 columns. B is a 2 by 1. Rows go first and then columns. So you've got 2 rows and 1 column. Now you can only multiply things if these 2 middle bits are the same. And you will get these 2 outside bits. So we've got 4 minus 1 minus 7, 2, multiplied by s minus 5 to give us minus 1t. So you're multiplying each row by each column. So essentially you've got 4 times 5 plus minus 1 times minus 5. Sorry, not 4, it's not 5, that's an s, apologies. Let's write that more clearly, s. So you've got 4s minus 1 times minus 5, making plus 5 equals minus 1. Okay, so we can solve that quickly. Bring the 5 onto the other side. So we get minus 6. So s is minus 6 over 4 minus 3 over 2. You might have written it as 1.5. Next one, we've got minus 7 times by the s, 2 times minus 5, and that equals t. So we end up with minus 7s minus 10 equals t. But we know s is minus 1.5. So we're going to do minus 7 times by minus 1.5. So you're going to end up with 10.5 minus 10, which must be 0.5. So s is minus 1.5 and t is minus 0.5. Excuse my voice. And then we've got AD equals I. Now what does that I mean? So that's your identity matrix. So I equals 1, 0, 0, 1. Essentially it's like timesing by 1 for matrices. When you multiply by I, you just end up with the same thing. So if I have A multiplied by I, I'm going to end up with I multiplied by A, which is just A. Okay, so A, it tells us, is 4 minus 1 minus 7, 2.
So 4 minus 1 minus 7, 2. D is 217U. And we're saying this equals 1001. So we know when we do this row, because this is the second row, by the first column, I get 1. So minus 7 times 1 plus 2u equals 1. So we get minus 8 plus 2u equals 1. And work out the value of u. So we've got A multiplied by D multiplied by D minus 7 plus 2u equals 1. Oh, I've made that 8 somehow. I wondered what I'd done wrong. I wish I could say it's to see if you're awake, but here we go. So minus 7 plus 2u equals 1. So 2u equals 8. So u equals 4. There you go. I knew it had to work out nicely. Also, in an exam, that's quite a good sense check. If you're getting a number that looks a bit strange, you might have done something wrong. So have a double check and go look back. Okay, next question. Work out the values of A and B. If we've got a number outside, it means everything is multiplied by that. So here, this means 3A and 5A. And on this side, we've got 4 times 2, so 8A plus 12. So it's like having a number outside of a bracket. So now I've got 3A equals 8A plus 12. So if I put all the A's on one side, 8 minus 3 is going to give us 5A equals 12. So A is, so if we do 8 minus, then we move minus 12, doesn't matter which way you do it. Whether you put the 12 on that or the one or the other side, just make sure you get the minus in. So A is minus 12 over 5. And then we've got 5A equals 4B, but we know that A is minus 12 over 5, so we get 5 times minus 12 over 5 equals 4B. So we've got minus 12 equals 4B, so B must be minus 3. So minus 12 over 5 and minus 3. The next one, we've got an identity matrix again, so we're going to be multiplying this out. So remember, we've got the first row times by the first column. So you're going to get 2 times m to give you 2m, minus 1 times minus 2 to give you plus 2, and remember the identity is 1, 0, 0, 1. So that equals 1. Then here you've got so then you can choose another equation. So let's do the one with 0. So we've got our first row, this time multiplied by our second column. M times 2, 2m. Minus 1 times minus 1 is going to give us plus 1, and that equals 0. And so we've got 2 equations. We could use either of them to work out m. I would use the first one, so we get 1 minus 2, so minus 1, m equals minus a half, and I would check it with the second one, so 2m equals minus 1, m equals minus a half. Because remember, you're in the exam, you want to try bring in checks wherever you can, just in case. Okay. So matrices allow us to represent transformations, such as enlargements, rotations, reflections. So, if I want to figure out which is which, you just take some arbitrary point, and you say, what happens to it if I do something to it? But there are some which are well worth learning. And if you learn them, it makes it a lot easier, and you don't need to think about the combination. So you've got a rotation, 90 degrees, anti-clockwise, and these are all about the origin. you're going to get 0 minus 1, 1, 0. 180 degrees is going to give you minus 1, 0, 0 is minus 1, which makes sense because you're changing them to minuses. In terms of reflections, you could have a reflection in y equals x. So your y's and your x's are swapping. You could have a reflection in the line x equals 0. And again, we can prove these and we will, but if you're good at learning and you've learnt them, it just makes it easier. And if you have any enlargements, the amount that it's enlarged by goes across the leading diagonal. That's what that first bit's called. And these zeros represent the origin where it goes through. Okay, so let's look at some questions. We've got two transformations, a rotation 90 degrees clockwise and a reflection. So now we're looking at the combined transformation. Now, with combined transformation, if you have A followed by B, that would be BA. So remember, it was always the second and then by the first. So in this case, we can say, well, 90 degrees clockwise. It's one of the ones that we have learnt. And your reflection. And we're going to put those in. And when we do that and times them up, we've got our first row times by first column, 0, 0, 1 times minus 1, which gives minus 1, 0, 1, that's just 0, so we get a 0 there, 0 and a 1. So that would be your single matrix that combines those two. Now say you'd forgotten what a reflection in the line y equals x looks like. There are different ways we can do that. So we're going to have a look at a few of them. Right, so now we've got this last question left here, and we're going to be looking at how we go from each of these. So if we've got a reflection in the line y equals minus x, and we don't know what the matrix is, we can think about what would happen to a unit square. So if I had a square here, I had the line y equals minus x, which looks like that, it would go here. And what you're really looking for is you're saying what happens to this point and what happens to this point. So this point here is 1, 0. And it goes down here, and what's happening to it? It's becoming 0 minus 1. Think of it almost like a coordinate. And this point here, which is 0, 1, is going here and become minus 1, 0. So actually, the reflection in the line y equals minus x results in a matrix where this becomes this, so that goes here, and this one goes here. So that's your reflection in y equals minus x. We've got a rotation of 90 degrees anti-clockwise in the origin. Now again, if you didn't know what that looked like, you would take your unit square, oh no, not reflection, sorry, a rotation. So rotation, 90 degrees anti-clockwise, and you say what would happen to that. So if I was to draw my unit square again, and I'm rotating it anti-clockwise, 90 degrees. So I'm saying to myself, what's happening to each of those points? So this point here, this point here, this point here, this point here. This point comes down, it's going to go here. So this was the point, like we said, 0, 1, and that's going to come down over here and become minus 1, 0. This point here, because when I bring it down, it's going to come here. This point here is the other point I want to think about. What happens to that when I rotate it about the origin? Now this point over here, which is at the moment 1, 0, So when I rotate that, that actually comes up to this point here. And those are the points that you're concerned with. So you say 1, 0 becomes 0, 1, and 0, 1 becomes -1, 0. And that's the same as that. If you have a look, that's the same as what we said over here for a rotation of 90 degrees anti-clockwise. Okay, then we've got a reflection in the x-axis. And if I, in exactly the same way, we think, okay, so this is my x-axis. You have our unit square here, it goes here, and I say, what happens to my first coordinate, which is 1, 0? Well, it stays the same. So that's just 1, 0. What happens to this one up here, which is 0, 1? It comes down here and becomes 0, -1. So that would be that matrix. Anyway, that isn't what this question's asking. It's asking us to say, what happens when we have all of these things followed by each other? So we're going to think of them as pairs. So we're going to have, and we're going to go sort of backwards, if you like. So we're going to take these two first, because remember, we're always going back. So we can take 1, 0, 0, -1, which was our reflection in the x-axis. And then just before that, we did 0, -1, 1, 0. We're going to multiply them first. So first row, first column, we get 0, -1, -1, 0. We then take this that we found, and we're going to multiply it by our initial one. And when we do that, we see we end up with 1, 0, 0, 1, which is the identity. And we've done that question. Okay, so the final question we've got for you today is a different shape. So we've got shape A matches by an enlargement. Now remember, an enlargement is going to look like, let's call it n, whatever the value of enlargement is, if that's around the origin. Centre the origin. Shape B is a rotation of 180 degrees. Shape A can go straight to shape C. And you're going to use matrices to show that it's an enlargement centre the origin. Okay, so our first thing we're going to do is we're going to say, okay, what's happening here? We've got our matrix and we are multiplying it by, so we take our matrix and we're going to multiply it by them by each other. Okay, so I would have 3, 0, 0, 3, which is my enlargement, and that takes me from A to B. So that's going from A to B. Then we've got a rotation through 180 degrees. So that was -1, 0, 0, -1, and that's going from B to C. So what we want to do is we want to multiply these together. Remember, it's the second one and then the first one. 0, -1, 3, 0, 0, 3. When we multiply them together, we're going to get -3, 0, 0, -3, which is an enlargement, scale factor, -3. Right. And
okay, circle theorems. Have something similar to this around you. And as you use it in questions, you'll learn it. Don't stress about learning it, just have a poster, write it all out, keep copying it in every time you use it in a question, and by the time you come to the 10th question, you'll know your circle theorems. Okay, so here we go. We've got A, B, and C are points on a circle. we want to work out the size of this angle over here, y. And we're going to look at this shape, and hopefully you'll notice that it looks a little bit like this arrow. So we've got like an arrow shape. Now the arrow rule is that the angle at the center, so this is the angle at the center, which is x plus 62, is twice, so 2 times, the angle at the circumference. So if we open this all out, we'll be able to solve this. So we'll get 3x equals, and we'll be able to solve it for x. So that's what we're going to start by doing. So if we take this one, we've got, so we get 4x minus x to give us 3x, and then we're going to have 162, and x is going to be 162 divided by 3 to give us 54. So that means we can now work out this angle at the center. So 54 plus 62, which gives us 116, is that angle over there. Now, what we should notice is that within this triangle here, we've got 2 sides which are the same because they're going from the center to the circumference. So both of them are radiuses. And we also know that the base angles of an isosceles triangle are the same. So we've got 116 plus 2y has to be 180. So 2y is going to give us 180 minus 116, so 64, and y is therefore 32. So we've got 32 degrees. Okay, next one. So in this question here, we've now got a tangent. So now we kind of think, what are my rules with my tangent? So we could have the tangent at, meets a line from the center and makes 90 degrees. That's one of them, so that's one of the rules. We haven't got 2 tangents, so we don't worry about this one. And then we've got the alternate segment theorem. Now, the alternate segment theorem, we've got to think about a whole triangle. I know this is split into lots of triangles, but the triangle there. And what the alternate segment theorem says, so if I get rid of this line, is that you've got an angle, you go into the triangle and you go across. And this bit here, therefore, is the same as 3x. Now, if we knew this one, we go into the triangle and across. So the whole of that A would be the same as whatever is there. So we know that CBA equals 3x. So all of this here, this whole thing here, is the same as this. And that's using the alternate segment theorem. It's not a proof, so we don't need to write out all the different steps. So that means OBA, so this angle over here, must be 3x minus 37. So we've got 3x minus 37. We also know we've now got the same as before, an isosceles triangle. This is also 3x minus 37. So OBA is that, which is the same as OAB. We know that angles in a triangle add up to 180. So we've got 2x plus 46 plus 3x minus 37 plus 3x minus 37 equals 180. So now we can collect our like terms. We've got 2x plus 3x to give us 8x. We're going to take all the numbers to the other side. So 180 plus 37 minus 46 to give us 208. And then we can divide by 8 to give us 26. So we get 26 degrees for that angle. Now you've got a question that looks a little strange. There's lots of things here, so let's read it through carefully. So we've got points on a circle. We've got 2 different circles. So what I'm going to do is draw them separately. Oh, and we're told that this is the center of that yellow circle. And we've got another circle over here. Okay. And we're trying to prove an angle. So now we've got to write all those rules out. So every time we use a rule, we've got to write it out now. So what we've got here is we have our, let's have a look. So we've got CA EF, which we're told is x, so we're told this one's x, and if you notice we've got that isosceles triangle again, so that must also be x. So that tells me that's going to be 180 minus 2x, because angles in a triangle add up to 180. We then also know that if that's the case, this is a vertically opposite angle, that's going to be 180 minus 2x as well. Now, if you have a look, we've got a four-sided shape within a circle. Now that is your cyclic quadrilateral. So that's a four-sided shape inside a circle. And what we know about that is that the opposite angles add up to 180. So that must be 2x, and that's what we were looking for. So now let's write that up in a way that you get all the marks. Because at the moment, we've worked it out, but we haven't written out our reasoning and all our different steps in order to get there. So we're going to start off by saying CFE, so it's always the middle one, so C to F to E equals X, and that's base angles of isosceles triangle. We also know that ECF is 180 minus 2x, and that's angles in a triangle add to 180. And then we can say DCB equals 180 minus 2x, and that's vertically opposite angles. And then finally, we get to BA, what have I written here? BC, that should be a D. BAD, which is 2x, and that's where we write the opposite angles of a cyclic quadrilateral add to 180. Okay, so that's this one here. All right, part B, it says, in the case when AB is parallel to DE, work out angle X. So we're now told that AB, all right, so I'm going to take this line here, it's parallel to this line here, and we want to work out X. Okay, what do we notice about DE? So DE goes through the center and it's this circle here. So we know that DE is a diameter. When we have a diameter and it goes to the edge, we always get a right angle. So now we know that we get a right angle there. So the next thing that we can do is we can now say this is a right angle. So if that's a right angle, and we know that this angle is X, and because you have parallel lines, we also know that you've got vertically opposite angles are going to be equal. So if you have a look here, you've got like a Z angle, and this is going to be 2x. So that tells me that's also going to be 2x. So what I'm going to end up with there is 90 plus 2x plus x must equal 180. So then we're going to end up with 3x equals 90, so x equals 30 degrees. Right, so I hope that makes a bit of sense. The next section here we've got is geometric proof. Now they aren't that many questions on it, and they all use different methods and different things to get there. But the important things about geometric proof and the things that people get wrong are not writing your proof. So not writing and constructing your argument. So you have to make sure you give reasons. So that's your pointer number one. Not just the angles, so you want the angles and their reasons. And if it's a proof question, you want to go in a logical order. So that's the most important thing here. Okay, so this question here, we've got a rhombus and we want to work out the area. Okay, so this isn't quite a proof question, even though I guess it came under it when we did it, when I looked up questions. So this is using the angles area of a triangle. So you've got 8 centimeters here. If you have a look, this is actually a rhombus is made up of 2 triangles, right? So if we have a look at ABC to start with, so we've got triangle ABC, we know that the area of a triangle, so one of the formulas we know, and if we don't have a right angled one, is a half AB sine C. Now this could easily come up in a non-calculator because you should know what sine 60 is. So you're going to have a half times 8 times 8 times sine 60. Okay, so we know that sine 60 is the same as root 3 over 2. So we've got a half times 64 times root 3 over 2. And so that's going to give us, that cancels to 32 root 3 over 2. But that's just one of the triangles. We've got 2 triangles and they're the same. So we say the area must be double that, 32 root 3. You could say times 2 and then 32 root 3, which is in the form that they're looking for. Okay, so now we've got our proof question. We want to prove that A to C is a diameter of this triangle. Right, now if it is a diameter, then we would know that ABC is 90 degrees, but we can't assume that. However, we have a circle, and as we worked out earlier, if we have a circle, and inside our circle, we have a 4-sided shape, so we've got a shape like this, opposite ones add up to 180. So we know that this plus this must be 180. So we've got x plus 2x plus 4x plus 3x equals 180. So that gives us 10x equals 180. So x equals 18. Okay, so if we know x equals 18, we now need to find out, and we'd say this is because opposite, because we're in a proof world, angles of a cyclic quadrilateral add to 180. We now should be able to find either CBA or CDA because we know what x is. So we'll say BCA equals 18 degrees. BAC equals 4 times 18 degrees because it's 4x, 72 degrees. That's just substituting values in. And then we've got CBA equals 180 minus 18 minus 72. Angles in triangle add to 180. So that gives us 180 minus 18 minus 72, which is 90 degrees. And then we can have to write a final sentence, which is essentially going to write this thing. So we say an angle subtended, that's like a fancy word, but essentially the angle at the circumference by a semicircle is 90 degrees, therefore AC is a diameter. And that would be sufficient for you to get all the marks. Okay, topic 3, we've got the sine rule. So that's written in 2 ways, A over sine A, B over sine B, C over sine C. So essentially, when we have something that's not a right angle, so we have a triangle that's not a right angle, we can't use SOHCAHTOA, we can't use Pythagoras. We have to use either the sine rule, or we do a bit later, the cosine rule. And remember, whatever the side of it is, the opposite one is what we represent with a small letter. Okay, so we've got here, we're trying to find angle X. I'm going to label some things. I'm going to call that big A, so that's going to be small a. big B, so that's going to be small b, and we don't need c, we only need a bit of this. Now, because we're trying to find the angle, we can also flip the sine rule and write it this way round. And if we flip it and write it that way round, whenever we're trying to find an angle, use the flipped version. So we're going to use sine A over A equals sine B over B. So we're going to have sine x over 2y equals sine 18 over y. Okay, so hopefully you can see you could multiply this y up here. So we'll get y sine x over 2y equals sine 18. The y's cancel. So sine x is the same as 2 sine 18. This will be in a calculator paper. So x must be shift sine, so 2 sine 18, which is 0.61 something something. Shift sine of my answer is going to give me 38.17. Now that's still not correct because they've asked me for an obtuse angle. And all you're going to learn to do any trig is 2 rules. You're going to say if you see sine, you get another angle by doing 180 takeaway. And if you see cos, you get another angle by doing 360 takeaway. So if x is 38.17, it's also, because it's a sine, 180 minus. So it's also 180 minus 38.17, and that's going to give you 141.8 or 142 degrees. Right, another triangle here. And we want to work out the value of x. So what we've got here is another sine rule, and the way, this doesn't tell you to use the sine rule, but hopefully you can see you've got opposites, right? And we're trying to find a side this time, so we're going to write it the other way around. So it's a small b, so we're going to b over sine b equals c over sine c. So b is the x that we're trying to find over sine 45 equals c, which is 6 root 2 over sine 60. Now this is non-calculator, so this is something you should know your sine 45, your sine 60, your cos 45 and so on. So you're going to have x over sine 45, which is the same as 1 over root 2. So x divided by 1 over root 2 equals 6 root 2, and sine 60 is the same as root 3 over 2. Okay, now if we times everything by 2, what's going to happen, just to get rid of like these denominators, because if you, well, let's think about what this means. So if you've got x over 1 over root 2, it's the same as x divided by 1 over root 2, which we change a divide into a times, so it's actually x times root 2. So this is actually root 2x. And the same here. If we were going to have 6 root 2 divided by root 3 over 2, it's the same as putting in a times sign and flipping the second one. So actually, it's the same as 12 root 2 over root 3. Now we want to get x on its own, so we're going to divide. So when we do that, we're going to do root 2, well, there's root 2's on both sides, so we can actually just get rid of those. So we get x equals 12 over root 3. Now if you notice, we don't like surds on the bottom. That's why you do all that rationalising. So we're going to multiply top and bottom by root 3. So we're going to get 12 root 3 over 3. That's going to cancel. Our final answer is 4 root 3. So a lot of those marks are just for manipulating the surds. And once you've manipulated them, you can see that it actually works out quite well, quite nicely. Okay, we all know Pythagoras. A squared plus b squared equals c squared. And we do that using A only if we have a right angle triangle. But when we're squaring something, particularly if we have x's or various numbers, we've got to make sure we square everything. So get used to writing the whole of whatever your A is inside a bracket. Okay, so here we want to find A to C. So we've got a right angle triangle. we're going to do a squared plus b squared equals what we're trying to find squared. So we've got ac squared is 3x, this is what I mean by brackets, all squared plus 4x all squared, which gives us 9x squared plus 16x squared, which gives us 25x squared. And then we're going to take the square root. Square root of 25 is 5, and we get AC equals 5x, as we needed to. So that's what we wanted to get, and we've got that now. Okay. Part B, we want to find the area of the quadrilateral. Okay, let's have a look at the quadrilateral. So we now know this is 5x, and they want the area of this entire shape. So 1, 2, 3, 4, which is why it's called a quadrilateral. And so we could say, okay, let's find the area of the other triangle, well, both triangles. We could start with the area of this triangle at the bottom, because it's a right angle, so it's easier. So we've got half the base times the height. So we're going to get 4 times 3, which is 12, divided by 2, which is 6. So the smaller triangle at the bottom is going to be 6x squared. And then we've got this other triangle at the top. Now, in order to find out or do anything with this triangle, we're going to need to find out an angle somewhere. Yeah. So what do we know? We're told that ACD, we're told this is isosceles. So we know that the base angles here are going to be the same. So the first step we're going to have to do is going to be to find that angles. But because it's an isosceles, what we can also do is split this in half. So we don't need to worry about any rules. And when we split it in half with a beautiful perpendicular line, which mine wasn't, you're going to get a right angle here. And this will be half and this will be half. So as I have to redraw that triangle, just half of the triangle, I'm going to have my right angle. That's my right angle. Actually, let's draw it the other way so it's facing the same way so you can see what I'm doing. So we're drawing here, here, here. We've got a right angle here. So the angle that I'm drawing is going to be, the triangle, that I'm drawing is this triangle here, which is going from D, if I call this just sort of midpoint, and C. We know that bit across is 5x, so this must be 2.5x. We don't know the height dm, but we know D to C is 6.5x. Now, in order to find out the area of the triangle, we want to find out this angle here. So we can find out this angle here. We've got the adjacent and we've got the hypotenuse. So using SOHCAHTOA, we're going to use cos. So we can see that cos x equals 2. So cos x equals 2.5x over 6.5x. These cancel. So I'm just calling this angle x. I know it's confusing. We should have probably called it x. Inverse cos of that, it gives me an answer of 67.4. So now I have an angle. I can use that same triangle formula, half base, or half A, B, sine, and then sine C. Right, we're going to stick that all into our calculator. So we're going to, without the x obviously, so 0.5 times 5 times 6.5 times sine of 67.4, which gives me 15.000. And then we've got x, which is x squared. So I'm going to say that's 15x squared. We had this 6x squared from the smaller triangle. So we add them up and we get 21x squared. Okay, the diagram shows a rectangle this time. So we've got a rectangle, we've got some measurements, and we want an expression. So don't freak out if you get asked for an expression for the area All you're doing is finding something in terms of x and y. Okay. And here we want, in its simplest forms, in terms of only y. Okay. So, the first thing we're going to do is we're going to say the area of a rectangle is base times height. So we'll get x times 2x, which is 2x squared. It's the area. But we've got no y's there, and they want it in terms of y's. So we've got to say, what's the connection between the three lines that we've got there? The connection between those lines is Pythagoras. So we've got x squared plus 2x all squared equals 4y squared. So we'll get x squared plus 4x squared equals 16y squared. Now we want to find out what 2x squared is in terms of y. So we've got 5x squared is 16y squared. X squared is 16 over 5 y squared. Therefore 2x squared is 32 over 5 y squared. And that would be our answer. Okay, next question. We've got a cone with a vertex and a centre. The slant height is 20. The angle between VA and VC is 38 degrees. So let's think about what that means. So VA and VC, where do those two lines meet? At V. So this is the angle that's 38. And we want to work out the radius of the base. Okay, so that's quite nice. We've got SOHCAHTOA, right angle triangle. And so what do we have? We want to find the opposite, and we have the hypotenuse. So we know that sine 38 is r over 20. So r must be 20 sine 38. When we stick that into my calculator, I'm going to get, 20 times sine 38. I'm going to get 12.3. And that's going to be the radius of that base. Okay. The next topic is 3D trig. So we often need to find, when we've got 3D trig, what we're looking for a lot of the time is like a triangle floating in 3D. Okay, I'm incredibly bad at drawing this, so let's see if we can draw something, otherwise I'm going to have to show you with an example probably. So if I have a 3D sort of cube, and what I would be looking for, so maybe I need, you'd have, say for example, a floating kind of triangle over here, inside this cube, right? What you have to think of is that everything is right angles. And sometimes they don't give you the side lengths, but they tell you it's a cube. So if they do that, make sure you choose the length to be either 1 or 2. So when you half it, if it's midpoints anywhere, you get to use it like that. So 3D trig is just about creating lots and lots and lots of triangles and remembering there's like right angles everywhere in a cube. Okay, or in a 3D shape. If it's something like this, which is a cuboid. So it's telling you that they want you to work out the length of AB. So let's see what we know. We know that HB is 34. We know that HD is 16. AD is 18. So we've got a few things there, and we want to find out A to B. Now what we can find easily, based on the information we have, is D to B, because we've got a triangle here. Remember, everything is right angles when we've got cuboids, and so we can use Pythagoras to find DB to start with. So D to B is going to be DB squared plus 16 squared is going to equal 34 squared. So DB squared is 34 squared minus 16 squared, which comes out to be 900. So DB must be 30. So now we've got 30, and then we've got another right angle triangle. So if we want to find out AB squared plus 18 oh wait, sorry, AB is my hypotenuse. So we're going to have, just again, 18 squared plus 30 squared equals DB squared, right? No, ignore me entirely. DB squared is my hypotenuse. Okay, let's try to do this properly. Apologies for that. Right, where is my right angle in this triangle that I have? I'm going to have DB squared minus 18 squared. So DB is my right angle because my right angle is here on the bottom here. See, you can see that AB is going to be your so DB is going to be your, oh my God, I can't get my words out today. So DB is going to be your hypotenuse, so which we know is 30, right? So let's rewrite this. Let's go again. Oh, we're going to end up with 18 squared plus AB squared equals 30 squared. So therefore AB squared equals 30 squared minus 18 squared. So AB equals the square root of that. So 30 squared minus 18 squared, which gives us square root the answer, which gives you 24, which makes more sense. There you go. All right, so let me go through that again and hopefully haven't confused you too much. This one at the bottom is your right angle. You're going to have right angles on the sides here and along the bottoms here. Okay, right, so you'll have to excuse whatever confusion I caused. Right, next one. We're going to work out the angle between HB, which is drawn there, and ABCD. Now the nice thing is they've drawn you the triangle essentially. So the angle that you're looking for is essentially this angle over here. So if I was to take this triangle, I know the opposite and I know the hypotenuse. So I'm going to use so sine. So I'm going to have sine x is opposite over hypotenuse. So sine to the minus 1 is going to give you 21.8 degrees. Right, next topic. We've got our trig graphs now. So we're getting there slowly, and my voice is going. So for trigonometry, you've got three graphs. You've got your sine graph, you've got your cosine graph, and you've got your tan graph. So let's have a look at all three of them. So we'll have 1, 2, 3. Okay. So we're going to have our sine graph to start with. So 90, 180, 270, or 360, always between 1 and minus 1. And what you need to remember with a sine graph is it starts at 0 and it's a sine curve. So what you want is you want to start at 0 and you get like a sideways S shape. Okay? So sine, sideways S, right? Y equals cos x, starts at 1 and you sort of get a bucket shape. So that's 90, 180, 270, 360. Now tan x is actually the same as sine x over cos x. Now we know it's illegal and totally wrong to divide by 0. So wherever cos x is 0, which is 90 and 270, you're going to get what we call asymptotes. It's definitely not going to go through that. Wherever sine is 0, it's definitely going to also be 0 here. So 180. And so what you get is this weird sort of like curvy graph like this. So those are your three graphs which you need to know because you'll need to manipulate them and do different things to them. Okay, so now we're told that cos 36 equals 0.8090. Okay, so that's somewhere between 0 and 1. Pick a point here. This is going to be 36. Okay. And then they're saying, so what does that mean? So minus is going to be, so this bit over here. Now remember, everything here is symmetrical. So essentially, the space that you have here is the same as the space you have here. So between 90 and 36, you've got 54. So 90 plus 54 is a 144. The other way, exactly the same with symmetry, if you don't want to do that, is that's 36. And therefore that is also 36, right? So we could do 180 minus 36, which gives you 144 degrees. So they're helping you out by giving you the graph there. So anyway, you just need 4 rules, remember, for angles though. Remember, sine, 180 minus x, cos, 360 minus x. Sine and cos repeat every 360, and tan is with plus and minus 180. Okay, so now we've got a graph of sine x. Now this is also going to use function stuff. Now remember, inside the bracket affects the x. X's are like your ex-friends, boyfriends, girlfriends, ex-anythings. They're annoying. They do the wrong thing. So inside the bracket affects the x. It does the wrong thing. If it says plus, it minus, minus means plus. Outside the bracket affects the y. The y does exactly what you expect it to do. So these ones should be nice. Let's have a look at them. We've got a sketch of y equals sine x. So we've got alpha is an acute angle, which means between 0 and 90. So, okay, we're going to pick our alpha. I'm going to say alpha is somewhere here. And we know when we do sine of it, we've got k over here. Right. Now, remember our rule for sine was 180 minus. So if we've got 180 minus, it's just exactly the same answer. Because if we go 180, this is alpha and this is alpha, and it go up, we're going to get exactly the same response. If we do 360 minus alpha, hopefully you can see it's just going to give you minus k. And then cos of alpha, so what's your connection between cos and sine? So what we need to know is we've got some rules. We've got tan x, we said was sine x over cos x. But your connection between sine and cos is sine squared plus cos squared equals 1. So if sine is k, k squared plus cos squared alpha equals 1. So cos squared alpha is 1 minus k squared. So cos alpha is the square root of 1 minus k squared. That's a little bit mean. We haven't really looked at the trig identities. We're going to start to look at them now. But that's the sort of thing that you'll see. So anyway, trig identities. So let's look at some trig identities now. So if we have a look here, what we've got here is there are 2 main identities you need to know. So what you need to know is sine squared x plus cos squared, and this is just a fancy way of writing sine x all squared. We just write it like that because it looks pretty, right? So sine squared plus cos squared is 1. Tan x is sine x over cos x. And let's remind ourselves of the other rules. So you've got them all on one page and it makes it easy to see. So remember sine x. So if you have sine, it's always, you find your one answer on your calculator and your next one is 180 minus. Cos, 360 minus. Tan is the easy one. You just keep adding and subtracting 180. Now, if you need more solutions for cos and tan, it repeats every 360. Right. The other thing that you should know is that you should know your geometry, and you may have learnt your angles by heart, but to understand where they come from, you've just got 2 triangles that you need to understand. One is an isosceles triangle, so 2 sides are the same. So if that's 90, this must be 45. Using Pythagoras, this is root 2. And that essentially tells us that sine 45 is the same as cos 45, which is 1 over root 2. So that's the first one there. And we can see that tan 45 is going to be 1. The other triangle that we use actually starts its life as an equilateral triangle. So it starts like an equilateral triangle where all the sides are 2 and all the angles are 60. So if you were to prove it from scratch, and then you split that in half and you end up with this triangle that we're going to have here. So that's 1, that's 2, therefore that's root 3. That's 60, so we know that one's 30. And from that we can find our sine 30, which is a half, sine 60, which is root 3 over 2, and then we've got cos 30, which is root 3 over 2, cos 60, which is a half, we've got tan 30, which is 1 over root 3, and tan 60, which is root 3. So those are for your non-calculator paper where you need to learn them if possible. And when you've got trig identities, you'll either get like provey questions or solvey questions. And we're going to come across one of each, some of each, and we'll go through them now. So it first says this is equivalent to this. So we've got to try and make this look like this. So we just take one side to start with. So we're going to take our left-hand side. We can see that we don't want any, this is, by the way, this is not 2, this is a square that's printed very nicely. We don't want any signs. So we look at our rule. We know that sine squared plus cos squared is 1. So that tells us sine squared is 1 minus cos squared, and cos squared is 1 minus sine squared. So we're going to replace the sine squared with 1 minus cos squared. So we end up with 6 minus 6 cos squared x plus 4 cos squared x. So let's simplify that. We can see here we've got 6 minus 6 plus 4 gives us minus 2. So A is 6, because that's the bit that matches there, and B is minus 2. So that's your first sort of type of question, which is sort of an equivalent question where you're matching things up. Now we've got to show that, and again, try to make everything into sines and coses. We know that tan x is sine x over cos x. And then we also know that sine squared x plus cos squared x equals 1. Okay, so 1 over tan squared. So we're doing 1 over sine squared x over cos squared x. Now remember, when we divide, we flip the bottom. That's minus 1 over sine squared x. So when we flip this one, we get cos squared x over sine squared x minus 1 over sine squared x. The denominator's the same. So we've got cos squared x minus 1. And what we can then do is hopefully see that's actually the same as sine squared, because we rearrange that. And that cancels and just gives you 1, which is a constant. So we've proved what we need to prove. Right, so cos squared minus 1, is minus sine x, so we get minus 1. So here's me jumping. Cos squared x minus 1, we'll move that onto that side, will be minus sine squared. Okay. Right, trig equations. So this is what we were talking about, where we've got these rules that we're going to use. Okay, I'm going to keep writing them. Hopefully, if you keep hearing them, they go into your head, and eventually they're going to become second nature. Right. So we've got our trig equations where we're going to use our our rules. So tan x is sine x over cos x, but also we know our 5 rules that helps us simplify things. So we've got sine 180 minus x, cos 360 minus x. These repeat every 360. We've got tan plus and minus 180, and so on. Okay. So we want to show that. So this is another proofy one. We know our formulas. And we sort of go, I'm not really sure, but I kind of want to get rid of the minus 1. So sine squared, but I don't know, there's a few ways you could do it. You could either change the cos squared into 1 minus sine squared, or the sine squared into 1 minus cos squared. and we got to figure out which one, will give you what you need. In this case, they both end up working out for you, but let's change the cos squared into a sine squared. So cos squared is the same as 1 minus sine squared. Right, and the reason I did that is I kind of want the ones to disappear, because I can see there's none on the bottom. So sine x, cos x. So I replaced here, what I've done is taken cos squared x and made it 1 minus sine squared x, and that's because I know sine squared x plus cos squared x equals 1. So therefore cos squared x is 1 minus sine squared x. So these cancel. 2 sine squared minus sine squared is going to give you sine squared x. Over sine x cos x, that's going to cancel, leaving you sine x over cos x, which we know is tan x. So now it's saying hence. You see the word hence, you're using the bit from the question before. If you didn't get it, it doesn't matter. Use the answer that they said show that and put it in. So we get tan x equals minus 1, right? So shift tan in my calculator of minus 1 is going to give me my first solution. So I'm going to do shift tan minus 1, and my calculator gives me minus 45. Right, I think what's my tan rule? So tan is just plus and minus 180, so we can keep adding 180. So to that minus 45, I add 180, I get 135. That's in my range. I add another 180, I get 315. And if I was to add another one, it would be outside the range. And then I cross out that one. So first I have my either 2 solutions if it's sine and cos, 1 solution if it's tan, add, get everything in your range, and then eliminate the solutions which are not inside your range that they've given you. Okay, here's another one. We're going to, I think this is our last question. We're going to show that 2 cos squared theta is equivalent to 2 minus 2 sine squared theta. So we start off with cos squared theta plus sine squared theta equals 1. Therefore, cos squared theta equals 1 minus sine squared theta. So we get what 1 that's cos squared theta, 2 minus 2 sine squared theta, and we've proved what we needed to. And then it says hence solve. So you're like, well, how does that help me? Well, we can see that this must be the same as this. So that's what we replace. So we get 2 minus 2 sine squared theta plus 3 sine theta equals 3. And when we're going to put everything on one side, you're going to get what we call a disguised quadratic. So it's like the equations that you factorize and it's hidden with the signs in there. Okay? So what we've got here is we're going to get 2 sine squared theta, I'm going to move it to the other side, minus 3 sine theta. 3 minus 2 is 1. So I'm going to move everything this side, plus 1 equals 0. And then you could, if you can't see it and it annoys you, you could say let x equal sine theta. So you get 2x squared minus 3x plus 1 equals 0. We could factorize that. So we get 2x and x, 1 and 1. And we're going to get minus and a minus, because that's going to work out. So we get x equals a half, or x equals 1. But x is really sine theta. So sine theta is a half, sine theta equals 1. On our calculators, we do shift sine of a half, and we get 30. The rule for sine, remember, sine is 180 minus. So 180 minus 30 gives me 150. And then inverse sine of 1 is 90. And that's all we need because that's our range. So we've got 30 degrees, 150 degrees, and 90 degrees. And that, hopefully, I know I've spoken for so long, so please, do what you need to there, use as much or as little as you need. So that is everything we have for geometry. I'm going to upload this just as a screen record at the moment, and we will prettify it and put it up properly for you. But just so at least you've got you've got it there, we'll try get that up for you tonight. Okay, I hope that's useful. Sign up for the course next week if you need it. We'll be going through some more papers and just lots and lots of questions. And what I'm going to try do as well is give you a summary of everything. So just like a really quick summary of some notes, and if you like, almost like a cheat sheet for your further maths. Right, hope that's useful. And any questions, ask away.